So today we will do the final 16 problems from our NeetCode 150 series. Now the other 134 problems have been completed in part 1, 2 and 3 of our NeetCode 150 series. If you have been able to complete all of these 3 parts and coming to the 4th part, massive respect to you for doing nearly 36 hours of LeetCode. I know it's not very easy to do. This NeetCode 150 list has been created by a YouTuber named NeetCode, and I tip my hat towards him for creating this list and sharing it with the world. Now I just have a small request to make. It takes a lot of time, energy and resource at my part to come up with this entire list and series. So I would appreciate if you can like, share, support the channel and become a member. And as a believer in free education, I believe in putting my stuff on YouTube available for free for everyone to use, and I rely on your support. So please support the channel, and that would motivate me to do more stuff like this. So now without any delay, let's get started with our NeetCode 150 remaining 16 problems. Hello friends, hope you are having a fantastic day today. So now we are going to solve a LeetCode problem called minimum interval to include each query. We can see that this one is a hard problem and also decently well-liked problem. The statement says that we are given a 2D integer array named intervals where any single value basically defines an interval with the left and right boundary that is inclusive of left and right boundary. Then we are also given basically an integer array called queries. And for any particular query value that is currently present, we need to return like an interval within the given interval array that contains that query or that value, and we need to return the size of the smallest such interval. So we need to first of all identify that which interval contains that query, and then if there are multiple intervals containing it, we need to find the one with the smallest size, and then we need to return the size. This is the formula to calculate the size of any particular interval, that is right limit minus the left limit plus 1, because it's right and left inclusive. So let's try to understand it with an example. Suppose this is our intervals 2D array that we are given. We can notice that there are 4 intervals given in total, and we are given 4 different queries that we need to find answers to. So let's go through queries one by one. So first query is query number 2. Now we can notice that this interval contains 2, this interval contains 2, and this interval also contains 2. So in this case, as part of the answer, we need to return the size of an interval that is the smallest that contains 2, which is going to be this one, because the size of this interval is going to be basically 3 minus 2 plus 1. So size is going to be 2 over here. So we need to return 2 as the answer. Same way for interval number 4. So this interval does not contain 4. This one do contain 4. This one does not, and this one do. Once again, let's compare the sizes. So size for this interval is going to be 5 minus 1, that is 4, 4 plus 1. So basically the size is going to be 5. Over here the size is going to be 9 minus 4, that is 5 plus 1. So size is going to be 6. So once again, this is the smaller interval and the size of the smaller interval is 5. So we are going to return 5 as the answer. Same way for 7, there is only one interval that contains 7. So basically we need to return the size of it, which is 6. And for 11, notice that there does not exist an interval that contains value 11. So we cannot fulfill this query. So in that case, we need to return minus 1. Okay, so this is the answer we need to return. Now, after understanding the problem, let's try to solve it using a simple brute force approach. Well, brute force approach seems quite obvious in this case, that we are basically given bunch of different intervals, right? If we take a look at this example that we currently have, and we have bunch of different queries that we need to find answers to. So logically in the brute force, what we can do is, whatever the query is, we can pick that query, iterate over each of the interval that contains that query, and then the moment we find that okay, there exists like let's say 3 intervals that contains the query, so find the sizes of each one of them, whichever is the smallest, put that size in the answer, and repeat the same operation for all the subsequent remaining queries. Now let's calculate the time complexity for brute force approach. Basically we have to do n work for all of the values that are currently present. For each of the query, we might have to iterate over every single value that is currently present in intervals. So basically once again we will have to do n multiplied by n work. So basically this is going to be big of n square time complexity for the brute force approach. Let's see if we can shorten this period by doing something smarter. And the answer is quite obvious. We are actually going to be using basically sorting in this problem to solve this problem. Now let's say that where does sorting comes into the picture. Number one thing is we have bunch of different intervals that we are given that we don't know. They can be random orders. So let's say that I'm trying to currently process a query number 5 and there are, let's say, 50 intervals present. Do I need to iterate over all of these 50 intervals? No. If I have sorted these intervals based on their start time all and end time, all I can say is the moment I hit an interval, let's say that contains the start time of, let's say, 6 to 5, something like the 6 to 7. If there is an interval like this, I know for a fact that all of these intervals are no use for me in order to find query number 5 or value number 5. If it has to exist, it has to exist between these values if the intervals are sorted. So first thing we are going to do is sort intervals based on the start time. Second thing is now same thing needs to be done for the queries as well. Now the thing is queries can also be unsorted. So we need to find match basically over here. For each of the query, it could be possible that there are multiple intervals that that query can have, and then we need to find the shortest. Or there could be some queries that does not have any interval. So basically we are also going to sort the queries, so that would make our life easier. Okay, so we are also going to be sorting the queries based on ascending order. Now let's see that what is the third smart thing we are going to do. And that is, I just explained that for each of the queries, it could be possible that there are multiple different options we have from which we need to select that what is the interval with the smallest size. So if there was a way for us to determine or store these sizes per interval in smart manner, it would be really helpful. And for that, we can actually use a priority queue or a heap. Basically in the heap, we would see that for any particular query, how many intervals that are currently possible. And let's say we identify that there are 3 intervals that are possible. We'll just sort them based on their sizes. So let's say that this could be of size 1, this could be of size 2, and this could be of size 3. So 1 would be the first, that would be the root of our heap. And then 2 and 3 would be like subsequent nodes, and they would be readjusted because it's a priority queue. Okay. After doing this, we'll also have to do one more thing smartly, and that is it could be possible that we could reach a query. Let's come back to our example like this value number 7. Now, if we are processing value number 7, and let's say that we have already processed this value 2 and 4. Now, in this case, we don't need to worry about all of these intervals because they are irrelevant to us, because 7 can never be there and we have already processed all the values that were coming before 7. So why do we need to keep these intervals in our priority queue? We don't. So that's what we are going to do, that whenever we are going to be processing any particular query, we would be checking that what are irrelevant nodes inside the priority queue, and if there exist in irrelevant nodes, we will just simply delete them. So this is the pretext of what our optimal solution looks like. And the reason that this is a hard problem is because of all of these steps that we'll have to do. That first we'll need to sort the intervals, then we'll need to sort the queries, and then we'll need to use a priority queue, and over there we'll need to delete irrelevant nodes in order to do it. Now mugging it up won't help you, so you will have to understand the logic on why we are doing each of these things. Okay, so I hope my explanation was clear. Now let me give you an example and we'll do a quick walkthrough. Okay, so let's say that this is the list of intervals we are given, this is the list of queries we are given. Now first thing we'll need to do is we'll basically need to sort intervals and sort queries. So let's quickly do that. Now sorting intervals it's not going to be very complicated because we only have to interchange these two values. Apart from that, all the other values are already sorted based on their starting values, which you can see over here. So let me quickly make that change. So this is going to be 7, 12, and this is going to be basically 8 and I think it was 8 and 10. Yeah. Okay, after doing this, next thing we need to do is sort queries. But thing is, we are going to be iterating over queries one by one to store their size and the intervals. So if we sort these queries, it could be possible that we might run into issue of finding out that what would be the correct order to return the answer, because we are returning the sizes. So what we'll do is we'll leave these queries as it is. Basically, we are just going to create a placeholder where we would be storing their subsequent index positions. Okay, so let's say that we'll just create a new array that is going to contain all the queries that are correctly ordered. Okay, but we are going to be returning answer based on the index values that we have already stored. Okay, so now we have the list of queries that we need to process. Now let's see that how does our heap is going to look like and what are the values the heap is going to contain. Okay, so first thing is we will try to process query number 2. Now in order to process query number 2, let's see that what are the nodes that can contain query number 2, and there are two nodes. First node is value 1 and 4, and second node is going to be value 2 and 5. Now if we see size of both of these, size is going to be 4 for each one of them, so we can just store them as it is. Now because we are processing query number 2, let's see that are there any irrelevant nodes inside the heap that are no use to us, and there are none because both of the nodes currently contains query number 2, so that's good for us. Now we will have to return the minimum size this query contains, and the minimum size is going to be, so let me just create an answer array over here. The minimum size is going to be 4, so I'm going to be marking 4 as it is. And remember, the query position is correct, so that's why this is the correct position where I'm returning. Next thing is query number 4 we are trying to process. Okay, so what are the nodes that contains query number 4? So this node contains query number 4, this node also contains query number 4, and there is one more node that contains query number 4. So let's just add node number 3 to 6 over here as well. Now if we add this node 3 to 6, what is going to be the length? This is also of size 4. So currently we have all of these as size 4, so we don't need to delete any of the irrelevant nodes. Okay, now let's see, the answer is going to be 4, but notice we are not going to be writing 4 over here because 4 is actually the third value inside the index position. So we are going to have an empty placeholder over here, and in the third position we are going to store the size as 4 for the second query that we process. Okay, now the third query we need to process is value number 5. Now for value number 5, notice that this first node becomes irrelevant because the ending value is 4, so it does not make any benefit for us to keep it in the heap, so we can just remove it quickly. So basically we would not have this node being stored. Now let's see that what are other nodes that we can include. So 7 to 12 we cannot include because the starting value is actually greater than 5, and all the other values would always be greater than 5, so we cannot include that. So currently there are only two nodes that can contain value number 5, 2 to 5 and 3 to 6. Both have the size 4, so we'll just store the size 4, but notice 5 is located in the second position or index position 1, so we will store 5 over here. Okay, now we will need to process query number 9. Once again for query number 9, notice that this 7 to 12 contains query number 9, and this 8 to 10 contains query number 9. So we'll have to include 7 to 12 over here, and we'll also have to include 8 to 10 over here as well inside the heap. But at the same time, notice that this 2 to 5 and 3 to 6 are irrelevant because there cannot be any further nodes that we can use it for. So we'll just remove it from our heap and only keep these two values inside the heap. Now let's just mark the sizes of these two values as well. So this is this is going to be the size 6, and this is going to be size 3. So if that is the case, 8, 10 needs to be the root of the heap, so which means 7 and 12 is going to come later, and this is going to be of size 6. So now the very first element is going to be 8 to 10 for this query number 9, but notice query number 9 is located on the last position. So for the last position, the size is going to be 3, so we'll just mark it as it is. And the last query we are trying to process is value number 11. Now notice that this 8 to 10 becomes irrelevant based on the last value, so we can also remove that. And now there does not exist any more intervals that we need to process, but there is value that currently contains query number 11, and that is 7 to 12, which is value number 6. So we can just mark size 6 as it is. and we can return this as the answer. So I hope the solution makes sense. Now let's try to analyze the time and space complexity. Okay, so time complexity is going to be basically, first we are going to be sorting the intervals. So that is going to take big O of, let's say, n log n time. Okay, plus we are sorting the queries. So that is going to be big O of m log n. Plus we are using a heap to basically go over queries and intervals. So that is going to take m plus n log n time, and this is the time complexity. So notice that, yeah, even though it looks longer, it's still significantly lesser compared to big O of n square time complexity. Okay, and if we see analyze the space complexity, because we will have to use an additional heap and an additional array to store the index position, basically we can just define it as big O of, let's say, n plus m, where m is the length of, like, total number of intervals, and n is the total number of queries, and that's what we are storing inside the heap and an extra array. So once again, I hope the solution made sense. You have to understand that why we are doing these things. And now let's quickly see the coding approach for this. Now the coding solution is going to contain a lot of steps. So let's go over them one by one. First, we are going to define the length of given queries as n, and we will be generating a result array to store the results. Then we are going to be storing the original index positions that are currently present inside our list of queries. Okay, and that is being stored in a new array called query indices. So that's where we are storing these values. Then we would be sorting the intervals, and we would be sorting the query indices. This is to basically make sure that we have sorted values, and we will initialize our min heap, that is going to be our priority queue, where the values are being stored based on the lesser size. And we are also going to have an interval index. This is to iterate over each of the values. Now in the for loop, first we are going to iterate over every single query that is present inside our query indices, and then for each of the queries we are going to check that what is the interval index that we are currently have, and what is going to be the length of that particular interval. We are also going to check that whether the starting value of the interval index is, if that is less than or equal to query or not. If that is the case, we will define left and right values. Then we will also check that we will only take care of the intervals that contains the query. So that would be done by comparing the right side of value. And after that, we will try to find that what is the smallest size value that is going to be at the top of the heap. So we can just do min heap dot offer, and then we will be updating our index to iterate over the next value. After that, we also need to remove irrelevant indices from the min heap, and that is to check that if what is going to be basically the right side limit compared to the query, and whatever the value is, we can just quickly pop that out. After it, we basically need to store the results. So that too we are going to do that. If we do find the value inside the min heap, we are going to be keeping it. If we do not find any value, we will return -1. So we'll try to keep track of the smallest in size indices that we can find. And I know it seems confusing, but if you just go over the code, it would be easy. Now let's try to run this code. Okay, seems like our solution is working beautifully. Let's submit this code. And our code beats nearly 55% of all the other solutions, which is pretty awesome. We can improve upon the space complexity. I can agree to that. But anyways, this is a very complicated problem, and it took like a lot of understanding of different concepts to solve it. So if you can solve it in an interview, kudos to you. It would be pretty good. So now the coding solution is present in our GitHub repository. Feel free to go and check it out from there. Thank you. Hello friends, we are still not employed by a FAANG company, so let's not stop lead coding till we get there. Today we are going to do rotate image lead code problem, and this problem actually has very real practical applications, as we know that there are a bunch of different softwares that allows the option to rotate an image. And if we see the list of companies where I want to join in and already have asked this problem, there are companies like Facebook, Microsoft, Amazon, Apple, Google, Bloomberg, Uber, TikTok, Nvidia, eBay, Paytm, and Robinhood. So that's why I'm paying my utmost attention. I hope you also enjoy the video. This is a LeetCode medium problem, and basically we are given an n cross n 2D matrix which represents an image. Now we need to rotate this image by 90 degrees clockwise. Also, one more thing that is mentioned, that we need to do it in place. We do not need to use an additional 2D matrix to solve this problem. So the space complexity has to be constant in this case. Let's try to see it with an example. So over here we are given a matrix like 1 2 3 4 5 6 7 8 9, and we can see that this particular row is actually converted to this column, which means that all the nodes have been transported to 90 degrees, which means this 1 has gone to this place, this 2 has gone to this place, and this 3 has actually gone to this place. And same goes for all the other elements, that this 4 has actually gone to this place, which we can see over here, and this 7 has actually gone to this place, which we can see over here. And the same way it is shown in this second example. Okay, suppose this is the input matrix we are given, which means that this is the answer for the 90 degrees rotated matrix. Now notice couple of interesting things in both of them. Well, over here the value 1 2 3 is in a row. So over here this value 1 2 3 is actually in a column. Same goes over here, that this value 4 5 6 is in a row, but this 4 5 6 is in a column, and same goes for the 7 8 9 7 8 9. So this is clearly a pattern over here. And basically what we can do it is that if we somehow convert this input to replace all the values that are inside the rows to be inside the columns, and then reverse those entries, so reverse all the rows, we would actually get a 90 degree rotated array. And let me quickly show you how we are going to do it. Okay, so suppose this is the original input. I have drawn it much bigger over here, and now what we are going to do is, for every single row we are going to place it inside the column, and every single column we are going to place it in the row, which means that currently at if we consider this position number 2, if we see the I and jth location, this 2 is actually located at the position 0 1, representing these two values. So what we are going to do is we are going to flip the values of the 0 and 1, and same we are going to do this for this 4, which means that this 4 will come to this place and this 2 will come to this place. The thing we did for this 2 and 4 we are going to repeat for all the other characters, and then we would have an array which would have where all the rows would have been converted to all the columns. Also, there is a name for the process of converting all the rows to all the columns, and that is actually called transposing a matrix. So first of all, we are going to transpose this original given input matrix, and we will see that the result would look something like this. So this 1 will remain at the same position because this 0 0 is at the correct place, so we can't change anything. Now this 2 is going to be replaced by this 4, which means that over here we would have 2 and over here we would have 4. Again this 3 is going to replace by this 7, so over here we would have 7 and over here we would have 3. So if we just notice right now, this row 1 2 3 has actually been converted to a column, and this column 1 4 7 has actually been converted to a row. We are going to repeat the same process now, and now this 5 will not have any impact because the position is actually 1 1, but for the 6 and 8 we will actually have to swap their values, that now over here we would have the value number 8 and over here we would have value number 6, and this 9 will remain at the same position because the value is 2 2, which means we can't do much about it. And now basically now we have created all the rows and converted them to different columns. Now the next idea is that we are going to put this in the reverse order, and if we reverse the rows for this transposed matrix, we can clearly see that we would get a 90 degree rotated answer. Let's do that. So over here the values would be 7 4 1. If we reverse this particular row, same thing we will do for this one. So the answer is going to be 8 5 2, and again for this one, the last row, the answer is going to be 9 6 3. And if we see, this is actually same as the answer we had achieved before, and I just draw all these 3 different matrices to give you an example that how we are going to do the things. But basically all of this activity can be done in place inside the single matrix. All we will have to do is we'll have to use a temporary variable to first of all swap the elements in this fashion, and then once that is done, we will need a temporary variable to replace the values inside the given matrix and reverse the rows. if we see the time and space complexity for this approach, basically for the time complexity, we will have to iterate over all the elements inside the given node to create this transpose matrix. And once the transpose matrix has been created, we will have to reverse all the elements, which means that the time complexity in this case is going to be big O of n cross n, but we will have to repeat this process 2 times. So which means we can say that big O of n cross n times 2, but in general we can just write it as big O of n cross n, and this would be our solution. In terms of space complexity, as mentioned earlier, we are not using any additional space, which means we are doing it in a constant space complexity, and this is a very good solution. Any interviewer would be really impressed with your approach, and this works for all the different n cross n matrix. Now let me quickly show you another solution for the same problem, where we don't need to do like this transposing activity, and we can actually solve this problem in a single go. So for the second approach, we are going to do things a little bit differently. First of all, I have drawn over here bunch of different matrix of different n size. So n is equal to 1, 2, 3 and 4 I have shown you. And now we are going to see that if we rotate them 90 degrees, can we see some patterns over here? So suppose we have a matrix of the size number 1. If we rotate this 90 degrees, it makes no sense. The value is going to still remain same. So we are going to keep it as 1. Now for this n is equal to 2, if we rotate this matrix by 90 degrees, actually the thing is going to happen is that this one node is going to shift one value to the right. This 2 node is also going to shift one value to the right. 4 and 3, all of them are going to shift one value to the right. And the answer in this case is going to be, okay, so first of all, we'll shift 1 over here, 1 value to the right, 2, and then 4, and then 3. So this is the 90 degrees rotated angle for this n is equal to 2. So basically what we have done is we have rotated all the values one place to the right, okay, for the outer layer. And in this case, since we only have 4 elements, which means the layer is only 1, we are good. So when we get to this n is equal to 3, things becomes a little bit interesting. And interesting how? Because we have the cells located on the outer layer, and we have one cell that is located in the inner layer. Now when n is equal to 1, when the number of cell that is located inside the inner layer, we know that the value is going to remain same. So even if we 90 degree rotate this particular element, it is still going to fall over here on the same place. We are not going to do anything special with this one. But for these other values, we will going to apply the same logic we applied over here, where because n was 2, we had to rotate all the values 1 degree to the right, or one place to the right. In this case, because n is equal to 3, we are going to rotate all the values to the two elements to the right, okay, and this would be the answer. So if we see in this case, this 1 is going to come at this place, this 2 is going to come at this place, this 3 is going to come at this place, and same thing is going to keep on repeating for all the other elements. And that is how we are going to find its solution. So let me quickly draw the solution for this outer layer over here. This is the answer for the outer layer of this matrix. And because in the inner layer we only have one element, and for one element we don't have to do anything special, the 5 is going to be at the same place, and this is going to be the solution, that we rotated all the elements couple of places to the right. Now in this case, n is equal to 4. So obviously for the outer layer, you can imagine that the pattern we are going to follow is going to be the same, that we are going to rotate all the elements 3 steps to the right, okay, so that is clear. But for this inner layer, we can actually see that this time we have a set of 4 values, which means we have a 2 cross 2 matrix inside. So over here we are going to use the same logic we used over here, where we are going to rotate them 1 step on the right. So first let's do it for the outer layer, and then we will do it for the inner layer. So the rotation for this outer layer is completed. Now for this inner layer, we will have to rotate them 1 times based on whatever we have seen when n was 2. So we are going to do the same thing. This is the answer of 90 degree rotated angle, which means one thing we can see over here is that we can have 4 pointers starting at this 1, 4, 16 and 13, and rotate all these values in place by using a temporary variable. Once that is done, we can repeat the same process for this value number 2, 8, 15 and 9. And again, we will keep on rotating them sequentially at the same time in place. and then we would be able to fill out our outer layer. Once that is done, we will come inwards and we will start filling the inner layer based on whatever the number of n we have. And that is the approach we are going to take. Okay, so suppose we have a 3 by 3 matrix, and I'm going to show you what is the approach we are planning to take. Now, this additional matrix I have drawn, that is only for the understanding purpose. Actually, we are going to do everything in just one single matrix, but I'm just going to show you that what are the value changes happening and how we are going to use this temporary variable to fix our problem. So first of all, we are going to store the value of this 1 inside our temporary variables. Okay, so the value inside the temporary variable is 1. Now what we are going to do is, first of all, we are going to project this value number 7 to this place 1. So this becomes 7 and this becomes 7. Currently this is the scenario. Now we are going to project this value number 9 over here, which means that this 7 is going to be replaced by value number 9, and this is also 9 at this at the current moment. Again, we are going to project this 3 to this 9, which means that the value of this 9 is going to be replaced by 3, and this is going to remain 3. And now at the final moment, we are going to take whatever the temporary variable we had and we are going to put it in this place, which means that this value is going to be 1. So at a single iteration, we have actually shifted values of all of these 4 places in its correct position. Again, we are going to repeat the same procedure for these 4 values, which means that over here now we are in the next iteration. Now the value of the temporary variable is 2. Now because the value of the temporary variable is 2, first of all, we are going to project this value number 4 to this place number 2, which means that currently both values are going to be 4, 4. Then we will project this value 8 to this 4, which means that this is already 8 and this value becomes 8. Then we will project whatever value of 6 we had at this position number 8, which means that this value would become 6, and this is already 6. And at the end, we are going to take whatever the temporary variable we had, we are going to project that value over here, which means that this 6 is going to be replaced by this value number 2. And once that is done, essentially in 2 iterations, we have taken care of all the values that were placed out in the outer layer, and we are done with this one. Now only thing we need to consider is this inner layer, and because for the inner layer n is equal to 1, which means that we can basically leave the value as it is, and this is the answer. And this is how we are going to able to rotate the entire element in 90 degrees in just like very few iterations. We don't have to do like transpose matrix and then replace all the values and change all the values. So even if we see the time and space complexity, in this case the time complexity is going to be big O of n cross n, but we only have to do it single times, and space complexity is going to be big O of 1 because we are only using an additional temporary variable to store some values. Apart from that, we are not using anything special to store any values. So we will initialize a variable called n, and we are going to store the length of the matrix for this one. Once we have that, we will have to iterate over this given matrix, and we are going to create 2 for loops to iterate over this given matrix. Now remember, we only have to iterate over half of the matrix. We don't have to do much work, which means that we are not going to iterate from int I is equal to 0 to I is equal to n. We are actually going to do it I is less than or equal to n plus 1 by 2. Now you will ask that why n plus 1 by 2? Because in the condition where the given n is odd number, we will have to take care of that scenario as well. So first of all, we are going to create a temporary variable, and we are going to store value of one of the elements inside this temp variable, and then we will start working on the flip operation for the remaining 3 elements. Once that is done, we will start iterating over all the elements. And once this loop ends, basically we would have rotated our matrix 90 degrees angle for all the elements. Now the question comes that how did I get this value of I and j? Actually, I could explain it to you, but I would expect that you draw any 3 by 3 or 4 by 4 matrix on paper and try to see that how we are getting these values of I and j, because that would be a very good exercise for you. Anyways, I would be posting this code in the solution, so you would be able to check it out. But still, I would expect that if you do it by yourself, you would never be able to forget it. Now let's try to run this code. Okay, seems like our code is working. Let's try to submit this code. and tada, our solution is actually 100% faster than a lot of other solutions. And basically we are solving this problem pretty efficiently. Again, I would be posting this in the comments so you can check it out from there, and there I would ask you to figure out that how we are getting these values of I and j compared to this value of n, and that would be a really good exercise for you to do at home. Hello friends, we are not employed by a FAANG company, so let's not stop lead coding till we get there. Today we are going to do spiral matrix lead code problem, and this problem has been asked by tons of my favorite companies. Companies like Microsoft, Amazon, Apple, Facebook, Google, Adobe, Uber, Bloomberg, TikTok, Walmart, Tesla, Paytm, Flipkart, ByteDance, eBay, Goldman Sachs, Robinhood, and Salesforce. So you can imagine that this problem has been really popular at top tier IT companies, and that's why I'm paying my utmost attention. I hope you also enjoy the video. So this is a LeetCode medium problem, and basically we are given an m cross n matrix, and we need to return all the elements inside the matrix in a spiral order. So suppose we are given matrix like this in a 3 by 3 matrix, we need to iterate over this given matrix in this following fashion in a spiral and return elements in that sequence. So to make things more understandable, I have drawn different matrix of different sizes, and let's see that what would be the spiral traversal for each one of them. So we will always start at the 0 0 position, and then we will start traversing on the right side until we hit a boundary. So over here we hit a boundary, and then because we hit a boundary we'll go downwards. Now again downwards we hit a boundary again we will go in the left direction, again we hit a boundary over here of the matrix. Now we'll again go upwards in the direction, but now this time we will not wait for us to hit a boundary. We will actually stop at this position number 4. Why? Because if we keep going in this upwards direction, we will end up at this position number 1, which is, though it is before the boundary, still this is the node that has already been visited, which means that we are traversing in a particular direction until the point where whether we hit a boundary or we hit a visited node. So this is a really important concept to understand. Now let's go back to the traversal. So again from this 4 we will come back at this point 5, and now from this 5 you can realize that there is no other direction this 5 can go to, and this would be the answer. So this would be the end of the traversal. Let's do the traversal for this 4 by 4 matrix. So again we start at this initial position, we start going on the right direction, then again we go downwards, again we go leftwards, then we go up until the point when we hit this visited node, again we go right, again we go down, and again we go left, and this would be the traversal. For this 5 by 5, let me quickly show you what would be the traversal, and of course it's pretty simple to understand, so I know you also know that what would be the traversal. This is how we are traversing in all three of the cases. Now remember that there are two important things to consider over here. First thing is that at any point we are traversing, we are always following a pattern in terms of the number of directions or the type of direction we are taking, and that pattern is always we start at the initial position, which is this one, and then we always go on the right side first. After going the right direction, we go downwards, so we go downwards. After going downwards we go leftwards, and after going leftwards again we go in the up direction, so we go upwards. Then again we go back on the rightwards, again we go down, and again we go left and right up, and we keep on following until we reach to a point where all the nodes that are adjacent to any particular node, so in this case this number 10, where all the other nodes they have already been visited. In this case it would be this node number 13 where all the other nodes they have already been visited. So we are traversing until the point where we exhaust out of all the nodes that we can traverse. And let's see that what would be the approach for us to solve this problem. Like we already know that what are the directions we need to traverse into, and we are always traversing in any particular direction until the point where either we hit a boundary or we hit a visited node, which means that these things are important for us to keep track of, that this boundary or this visited node, we need to understand that how to identify them, how to keep track of them, and what are the different approaches to tackle both of these, and what would be the solution. So in order to solve this problem, there are actually two different solutions. I'm showing you both of them. You can pick whatever you want to. Both have its pros and cons, and you can discuss it with your interviewer which solution you want to pick. So let's go with the first one. Now first approach is that we actually start shrinking the boundaries and we don't care about visited nodes. How we are going to do it, let me quickly show it to you. So first of all, we always start at this initial position. We know the directions we need to take. We go right, then we go down, then we go left, and then again we go up. This is the state of direction we are going to follow. Let me also create our answer of the nodes that we are going to traverse along. So first of all, we start at this position number 1, and then we follow up until this point where we hit a boundary over here. Now the moment we hit a boundary over here, we are going to add all of these values to our answer. So let me quickly add all the nodes to my answer. And then because we hit a boundary over here and this was the direction, right direction, we know that next direction we need to go is downwards. So we start going downwards, but we are going to do one thing important over here, and that thing we are going to do is we are going to ignore all of them and we are going to actually shrink our boundary up until this point. So originally this matrix was actually 4 by 4 matrix. Now we are going to convert this matrix to be a 3 by 4 matrix, and we are going to ignore this first row as if that never actually bothered and that never actually existed. So by doing so, what we are doing is that we don't need to take care of these elements, and since we have already added them to our answer, so they are always going to be in our answer as well, right? Now again we go downwards in the same path until the point where we hit a boundary. So we hit a boundary over here. We are going to add all the nodes to our answer. So nodes would be 8, 12 and 16 in this sequence, and again we are going to ignore all of them because we have seen all of them, and now again we are going to shrink our boundary up until this point, and we are going to ignore all of these places. So let me actually remove them, that they never existed for us. Now again, after downwards we will start traversing on the left direction. So we go until this point, we will add all the entries in our answer, and again we are going to delete all of them because they never existed for us, and our boundary actually shrinks even further. And after that we start going in the upwards direction. But notice over here we don't have to care about these nodes because we have already shrunk our boundary to only consider up until this point, which means that we are going to add this values 9 and 5 and again shrink our boundary, and then we will add this value 6 and 7, again shrink our boundary, add value number 11 and then again shrink our boundary, and in the end we are only left with one value, value number 10, and we will add it to our answer, and this would be the answer that we need to return. So this solution works perfectly fine. We don't have to bother keeping track of the number of nodes visited because we are shrinking our boundary with every single iteration. And let's see that what are the pros and cons of this one. So first of all, we'll try to calculate that what is the time and space complexity for this one. So time complexity is actually going to be big O of m cross n. Why m cross n? Because we have to iterate all the nodes inside the given matrix. So that is a given thing. Now in terms of space complexity, we are actually doing it in a constant space complexity. Like you can't consider this answer to be a space complexity because anyways we have to return a list of all the nodes that we have traversed. So that is part of the answer, that is not part of our algorithm, and that is why this is a very good approach. And you can discuss with your interviewer that if he is okay with this approach, you can also move forward with this one. Let me show you what would be the second approach. So for the second approach, we are actually going to keep track of the visited cells and also the boundaries, and whichever we hit first, we are actually going to change our direction. So one thing remains common is that we are always going to traverse in the same sequence of direction. So first of all, we will traverse in the right direction, then we will go in the downwards path, then we will go in the leftwards path, and then we will go on the upwards path. So this will remain common, and then we keep on repeating, and at any moment we hit either a visited cell or we hit a boundary. Originally we are at this position number 1, and we are going to mark all the coordinates of the matrix. So the coordinates of the matrix is going to be 0 1 2 3 and 0 1 2 3. Now current position of this 1 is actually 0 0, we can see over here. So what we are going to do is we are going to create a hash set, And inside the hash set, we are going to first of all check that whether the coordinate that we are visiting, have we visited it already or not. If we have not visited it, we will add an entry to our hash set. So at this position number 1, we will add an entry to our hash set saying that okay, currently we have already visited this coordinate number 00, and we are also going to create our answer list, and inside the answer list we are going to mention all the nodes that we have traversed, which we need to return in the end. So we'll add this entry number 1, and then we will keep iterating on this direction on the right side until we hit either a boundary or a visited node. Remember, either a boundary or a visited node, both the things we are keeping track of. So, and at the same time we are going to add all the entries. So in this case we would have added entries like 00, 01, 02 and 03. All the things we have added, we have already also added it to our answer that we have already traversed this nodes 1, 2, 3 and 4. And now we know that because we have hit a boundary, it is time for us to go in the downwards direction. So again, we will go in the downwards direction until the point we hit a boundary, and we would have also added all the values to our hash set as well again, and also to our answer list as well. Like, I am not going to bother writing all of them, but I can understand that you are smart enough to understand that. Again, we go on the leftwards direction until the point we hit a boundary, and again we start going on the upwards direction. But notice that when we are going in the upwards direction, we are actually going up until this point number 5. We are adding all the values to our hash set. We are also adding all the values to our answer. Now at this 5, when we try to go this position number 1, we would first check that okay, whether this position number 1, which is located at the coordinate 00, have we visited it already or not. And we would identify that okay, the 00 has already been visited, which means that because it has been visited, we actually don't need to go and do that again. Or what we need to do is change our direction. So from this position number 5, again we would change our direction in the same manner where we would have changed our direction if we would have encountered any boundary. So then again we will add all those entries 6 and 7 and again add them to our hash set, and then we keep iterating until we reach to the end of all the entire matrix, and we would have visited all of them. Now this solution works perfectly fine. Now, but the thing is, you would immediately say that hey, this solution actually we are using an additional hash set, which means that for the space complexity we are actually using big O of m cross n space complexity, which means how come this solution can be better? This is actually a bad solution. So your interviewer is definitely going to let you know that okay, you can't use this hash set to keep track of all the visited nodes. In this case, what we are going to do is, there is another solution to solve this problem without keeping track of all of the visited number of nodes. So at any position, if we have visited some node, what we are going to do is, we are going to add it to our answer list first, and then we are going to change its value. And how we are going to change its values, we are going to put something random that is out of bounds, or it doesn't even make sense. So over here, suppose we are at this position number 1, and then we start traversing this 1, 2, 3, 4. So we have traversed 1, 2, 3, 4, we have added it to our answer, and then at the same time, the moment we are done with traversing through any node, we are actually going to change its value to something, let's say minus 100, or let's say value number false, or something like that, right? Anything that is not that can never be a part of this matrix, and we need to replace our value with this one. So let's say in this case we replace our value with this minus 100, considering that this would not be a part of this matrix. Like, it can be, and then you can change this value, you can discuss it with your interviewer, and then again we start iterating in the same fashion. So again we would have added all the values to our answer list, and again we would have changed all of its values to whatever the value we decided, and we are going to keep repeating the same work up until this point. And notice that at this position number 5, when we try to go upwards, we are going to check that okay, if the value of this particular cell, if that is not minus 100, then only we can say that okay, this node has not been visited, and then only we will add it to our answer. But the moment we find out that okay, this value is actually minus 100, which means we have already visited this node and added to our answer already. So now we have to change our direction in the same manner where we would have changed our direction if we had encountered any boundary. and then we would follow the same path and we would be able to solve this problem. So if we see the time and space complexity, in this case the time complexity is also going to be big O of m cross n, and the space complexity is actually going to be big O of 1 constant time space complexity. Now you would argue that the issue with this approach is that we are actually changing whatever the given input is, and that is not a bad practice, that is not a good practice in when you are actually doing inside the job. But when you are giving any competitive coding interview, your interviewer might expect you to do it, so it's always good to know a better approach. Let's move on to coding now. So first of all, we are going to create an integer called visited, and we are going to assign it some random value. So let's assign 101. Also, we are going to create two variables to keep track of the number of rows and number of columns we have. After that, we are going to have a couple of variables to keep track of the row position and column position we are at, and we are going to initialize it to value number 0. Now we have to iterate over our 4 directions. So we are going to create a 2D array. We are going to name it as directions, and we are going to iterate over all the 4 directions. So we are going to have 4 coordinates that would be used to go to any direction we want to. And we are going to maintain a sequence where the first would be to go to right, then next would be to go to down, then left, and then up. Now we need to keep track of what is the current direction we are at and when we need to change the direction. So we are going to initialize couple of variables called current direction and the change direction, and we are going to assign the value 0 to both of them. So we will have to create an array list to store the result. So we are going to initialize a list of integers to store the answer. Inside our answer, we are going to add the first node of our matrix, which is located at position 0 0. And after that, remember, every time we go through any value, we will have to update that value inside the matrix, because I am showing you the implementation for the second approach I showed in the explanation video. So we will update the value of this matrix node to this visited element that we already set up. Now we will start iterating over our given matrix, and we are going to have few conditions. So first thing is we need to iterate over the given matrix. Also we have to iterate over in a particular direction, and the moment we encounter a condition where we are either reaching a boundary or reaching a visited node, we will have to change the direction. So we are going to use current direction and change direction and make conditions around them. So first of all, we are going to have a while loop, that while the change direction is actually going to be less than 2. And why less than 2? Because we have 4 directions, and at any point we can only go in one direction, and when we are the maximum amount of patterns we have is either we can go on right down or left up path, and that is what we are going to use. Once that is done, we will have another while loop that takes care of all the possible ways where we need to restrict our matrix. First 4 conditions would be to check that whether we are hitting a boundary, and the last condition is to check that whether we are hitting a visited node or not. If none of this is true, first of all we will have to reset the change direction to 0, because we are not breaking any direction. After that, we are going to update the value of row and column. Then we will add the current matrix row and column position to our answer array list, and then we will update that value for that particular row and column position to visited value. And after first loop ends, we will have to update the values of the current direction and change direction. So for the current direction, we are actually going to add a value, and then we are going to modulate it by 4. We will have to update the value of our change direction. And after both the loop ends, basically our answer array list should have all the elements, and we would have traversed the matrix, so we can simply return that. Let's try to run this code. Okay, seems like our solution is working. Let's submit this code. and our code actually runs 100% faster than all the other solutions, which is pretty nice. Also, I have created a GitHub repository where I'm storing all the problems that I have solved so far, and you can go to any problem and you would be able to find the Java solution for that, and you can use it. It's quite helpful, and I would be posting this link in the solution as well, also this solution in the comments as well, so you can check it out from there. Thank you. Hello friends, we are still not employed by a FAANG company, so let's not stop lead coding till we get there. Today we are going to do set matrix zeros problem, and this problem has been asked by some of my dream companies. So companies are like Microsoft, Amazon, Facebook, Apple, Bloomberg, Adobe, and also sometime in the past there have been Google and Goldman Sachs and eBay. They all have asked this problem, and that's why I'm paying my utmost attention. I hope you also enjoy the video. So this is a LeetCode medium problem, and it is a very well liked problem. Basically, we are given an m by n integer matrix, and we are told that at any point if we identify that there exists an element that is 0, then we need to set that entire row and entire column as 0. And we are also told that we need to do it in place. So let's see it with an example. So over here in the example, we are given a matrix like this in the input, and we can see that this is the element that is 0. So because this element is 0, we will have to convert this whole row and this whole column to and set it up to zeros, and we need to return an answer like this one. Same goes with this second example, that we are given a matrix like this where we are given two zeros at these two locations, and because there are two zeros, we will convert this entire row and this entire column to 0 because of this particular 0, and we will convert this entire row and again this entire column to 0 because of this particular node. So this row is common, so anyways we will just convert it to zeros, and this would be the final answer we need to return. So suppose this is the example that we are given, and let's see that what could be the most basic intuitive approach that comes to our mind. Well, first thing that comes to our mind is that we can actually start iterating over whatever this given input is, and the moment we encounter a value 0, we can just convert that column and that row where the 0 belongs to all and set it up all to all the zeros. And let me show you that why it won't work. So first of all, we'll start iterating over here. We cross this node and this node. We don't find any zeros, so we are good so far. Now at this point, we identify that there exists a 0 over here, which means that for this particular column and this particular row, we will have to convert it to 0. So let's just do that. So if we do that, what we will basically do is we will remove all of these entries, and now we will convert these entries to zeros, which means that this is 0, this is 0, and this will all become 0. Now the problem will happen that after iterating this element, the moment we reach to this particular node, we will again have to convert all of these values to zeros as well. But remember that should not have been done. Why? Because originally the value over here was actually 1, which means that this particular row, this particular column does not need it to be converted to 0 because of this particular node. So that is the problem over here. Let's see that what could be the solution. So let me quickly draw back this to its original form. One thing we can do is we can actually create a copy of this one, and in that particular copy we can actually start making the change whenever we find a 0 in this particular matrix, so that we do not end up changing the elements before they are being visited. So let me quickly create a copy of this particular node. Okay, so now we have created a copy. Again, we'll start iterating over all these elements. We won't do anything over here. We identify that this is a 0 element. The moment we identify that this is a 0 element, we will actually make changes to this particular copied element. So now we will update the elements in this particular fashion, so all of these would be converted to 0. Now again we start iterating over this one. So this is 1, this is 1, so we are good. This is also 1, so we are good. Now this is again a 0. So because this is a 0, we will again update this row and this this column and this row in the copied node. So let me quickly make those updates, and this will be the solution. So in the end, we can actually return this copied solution where there is only one entry over here and all the other elements are 0. So this solution would work, but the issue is that we are actually using a big O of m cross n space over here. So let's try to see that can we do some improvement rather than using this additional space. Okay, so in the previous approach, we used a new matrix to keep track of all the elements where the rows and columns, the entire things needed to be turned out to 0. But this is actually not necessary. Remember that at any point we identify that inside the given matrix, if there exists a 0, all we need to do is we need to convert that entire column and row, set it up to zeros, which will happen in both of these cases. So because at any point we identify a 0, the change applied to entire matrix for that particular row and column. Why do we use the entire additional matrix to store all the values? This is useless. And better approach is that we can actually create another set where we take care of all the row positions and all the column positions, and all we need to care is that at any point if we identify a 0 at any moment, we simply need to enter that entry in those particular row and column positions and then convert those row and column position to 0. So let me quickly show you how we are going to do this. So over here we will start iterating all the nodes, and we identify that these particular nodes 1, 2 and 3, these nodes, they are not 0, so we are okay with this one, but this is a 0. So because we identify that there exists a 0 node, we will quickly note this position to this row and column entries. So we will add an entry over here called 0, and we will also add an entry over here called 0, right? We are good so far. Now again we will keep iterating over this given input in the similar fashion. So these two are also not 0 and this is also not 0, so we are good so far. Next we are going to do is that because this entry is 0, again we will record those positions inside this additional row and column set that we have created. And now this last entry is also not 0, which means we don't care about anything. And at the end, all we need to do is we need to iterate over this additional created sets and see that at whatever position we encounter the 0 value, for that particular row we will convert it to 0, and that particular column we will convert it to 0. So first of all we will visit this hash set of rows, and we identify that okay, first one is 0. So because first one is 0, all of these entries needed to be converted to 0, so we will convert these entries to 0. So we are good so far. Again we identify that second is also 0, so again we will repeat the same thing, and we will get rid of all of these ones and we will convert them to zeros as well. Now this last one is not 1, so we are good, and we will not touch this particular column. Now we will do the same thing for this one. So this is because this is 0, we will convert all of them to 0. So this becomes 0, and this one is also 0, so we will convert all of them, and this last cell also becomes 0. And in the end we can just simply return this newly created matrix. So this is a much bigger improvement than that in the previous one we were actually storing an additional entire matrix where the space complexity is big O of m cross n. So over here the space complexity is actually improved, and we are only using big O of m plus n. Why plus n? Because suppose the number of rows are m and number of columns are n, so we are still creating this two additional hash sets with those particular element values. The question is, can we actually do something better and even not using this m plus n space, and can we actually use the space complexity to be big O of 1? And yes, there is a solution that achieves this in big O of 1 as well. So let me quickly show you how. Okay, so previously we were actually using an additional data structure like this one to keep track of all the rows where we need to change the value to zeros. So over here, suppose we identify that there exists a 0 over here, we would update that value in this particular place, and later we would know that hey, we need to convert all these values to zeros. And we were also using another data structure to keep track of number of columns that needs to be converted to 0 in the same manner. That over here we identify that this is a 0, we will update an entry over here, and we will mark this point as 0, and later we would update all of these nodes to zeros. But rather than using this separate nodes, what we can do is we can get rid of them, and we can do the same thing by using this first row as an alternative for this original additional data structure, and also we can use this first column as an alternative for that original column data structure. And basically we will do the same concept, but we won't be using any extra space anywhere, and this is a wonderful approach. Now there will be one problem with this one, and the problem would be that over here we would be using this particular row to keep track of all the columns where the value needs to be converted to 0, and same way we will have to use this particular column to keep track of all the nodes where the rows needs to be updated. The problem is that this particular position is actually a point of conflict where there exist two intersecting nodes. So what we will do is, as a solution, we would actually create an additional node, and we will use these two nodes. So these three nodes would be working in combination, and for the first column we will need to do is just use this entire first row to keep track of all the columns that needs to be updated. And let me show you that how we are going to do the things. Okay, so first of all we will iterate over this matrix, and we identify that okay, this value is 1, so we don't care. This value is also 1, so we don't care. Now this value is 0, so because this value is 0, we will have to make change to this particular row and this particular column. But this is at correct position, this 0 for this row, so we only have to update it over here. So we will add an entry 0 over here, right? Now next thing we will do is we will keep iterating over this matrix. So we'll we'll check these three values, and all of them are 1, so we are good. This is also 1, so we are good. Now this value is 0, so because this value is 0, we will have to update over here and also over here. So we will do that. So we will convert this value and convert it to 0. We will also convert this value and change it to 0, and at the end we will just iterate over this element, and this element is already 1, so we don't have to do anything. Now this is the matrix we have. All we will have to do is we'll have to iterate over this and these 6 nodes, and at any position we identify the 0, we will convert that row or that column and change it to zeros. So first of all we will start iterating over this first row, and this is 1, so we are good. But this is 0, so because this is 0, we will have to convert all of these to 0. So let's do that. So this value would be turned to 0, and we are good. Now again we come at this position, this is also 0, so all of these values needs to be converted to 0. So we will flip all of those values to zeros as well. Okay, now we are done iterating over this first row. Now we will iterate over this first column. So for the first column we identify that okay, this particular position is 0, so because this is 0, we will update this entire row as zeros. So let's do that. So we will get rid of this first value and we will change it to 0. Now we will iterate to this next node. So this is 1, so because this is 1, we will not touch this row, so we don't have to do anything. And because this is 0, so because this is 0, we will have to convert this entire row to zeros. But since these two nodes have already been converted to 0, we don't have to do anything, and this would be our final solution. So if we write the answer, we can actually write an answer like this one. This would be our final answer, and we can actually return this as the answer, and this solution works perfectly fine. Let's see the time and space complexity in this case. So the time complexity is actually going to be big O of m cross n. Why? Because we will have to iterate over this entire matrix, and that takes m cross n time. In terms of space complexity, we already know that we are only using this additional node. Apart from that, we are not using any additional space, so the space complexity is actually constant space, and this is the final solution. This solution is very good, and let's see the coding. First of all, we will create an additional variable, and we will create a boolean variable, and we will just name it as first column. We will initialize the value as false. And now we'll have to iterate over the matrix, so we'll need to know the length and height of the matrix. So let's initialize two variables to store the height of row and column of the matrix. Now we'll start iterating over the matrix, and we'll start updating the value inside the first row and first column. So we will check that if inside the given matrix for the first row, if there is any element where the value is actually 0, then we will convert that and we will update the value of the first call variable. Okay, once that is done, We will also have to iterate over all the columns, so we will create another loop inside the loop. And now we simply have to check that whether at any position we are encountering any value that is 0. If there is any value that is 0, we will have to update the corresponding I and jth position inside the first row and column subsequently. So once this loop ends, all the values should have been stored inside the first row and first column. So all we will have to do is iterate over the first row and first column, and we will update the subsequent rows and columns. So we will check that if at any position the corresponding value for the I and jth position, if that is 0 inside the first row, we will have to update the element of the this particular node inside the matrix to 0 as well. And once this loop ends, we would have taken care of all the elements inside the given matrix. But we notice that we are running this loop from I equal to 1 and j equal to 1, which means that we are not taking care of first row and first column. So we'll have to take care of first row and first column. Now remember, in order for us to take care of the first row, we will have to check the very first element, which is this particular element inside the given matrix. So we will do that. So we will check that if matrix at 0 0 position, if that is 0, we will have to update all the values inside the first row. And once that is done, we will also have to check for the first column. So for that, we actually have a variable first column, and if the first column variable, if that is true, then we will have to update the first column to 0. And after this ends, I think we should have taken care of all the nodes. So let's try to run this code. Okay, seems like a compilation error. Okay, seems like our solution is working. Let's try to submit this code. Our submission did not work for this one. Oh, we'll have to start from j equal to 1 inside this first column. So let's try to run the code again. Let's try to submit it again. Okay, seems like our solution is working, and it's actually pretty efficient compared to a lot of other solutions. I would be posting this inside the comments so you can check it out from there. Also, I have created a repository inside the GitHub where I have posted the solution of all the Java problems that we have done so far inside the LeetCode. Okay, so this is the repository. You can go to any problem, and you would be able to find the accepted Java solution for that particular problem, and I would be posting this link inside the description as well, so you can check it out. So the LeetCode problem we are going to solve now is called happy number. Now we can see that this one is an easy problem and also an extremely well-liked problem. The statement is quite straightforward. We need to write an algorithm to determine that if the given number n is a happy number or not, and we are given the conditions that how can we define a number to be happy. Now it is quite straightforward that starting with any positive integer n, we need to replace the given number by the sum of the squares of its digits. So let's say that we are given a digit like 16, right? If n is equal to 16. In this case, we need to replace n with the square of its digits. So current digits are 1 and 6. So we need to do 1 square plus 6 square. So this is going to become 37. And then once again, we will need to do the same thing for the 37 as well, where we would do 3 square plus 7 square. So this is going to be 9 plus 49. So I think it's 58. And yeah, so on and so forth. We would keep on repeating this. Now we need to repeat this until either the number equals 1, where it would stay as it is, or it would loop endlessly in a cycle which does not include 1. So either we need to keep on doing this process until this becomes 1, or until we find out that there is actually a cycle that is happening. And there are only two possibilities: either it could be a cycle or it could be 1. Now for those numbers in which process this ends in which ends in 1 are defined happy, so we need to return true for them, and all the other ones we need to return false. Okay, so let's try to understand how we are going to solve this problem by an example. Suppose the given number n is equal to 19, right? So in this case the square is going to be 1 square plus 9 square, so basically 81 plus 1, so 82. Once again for 82, so it's going to be 64 plus 4, so 68. Now for 68, so total is going to be 100. Now for 100, it's going to be 1 square plus 0 square plus 0 square. So basically this is going to become the value as 1. So because we find value to be 1, we can define 19 to be a happy number, and in this case we can return true. Now let's take one more example. Suppose the given n is equal to 2. This is going to be the full sequence and this is the full math behind it. So you can notice that I have marked all the values defined as circles, and if you want you can just pause the video at this moment and notice the numbers. But overall notice that we start at 2 and at some point we end up at 2 as well, and if we keep going forward then next value would be 4 and so on and so forth. So we would be in an infinite loop. So in this case we can define the given number n is not a happy number, so we can return this as false. So this is the ask of the problem. Now let's try to see the solution. Now for this solution, brute force basically doesn't make that much sense because it's quite straightforward. We only need to take care of that whether n yields in value 1 or if n yields in a cycle. Now we know whether if n yields in value 1 or not. That is quite straightforward and easy to understand. We can we can have a method that basically get the square of the sum of given values, and basically for the given value we keep on repeating the process for given n, where let's say if the n value is going to be 55, first we do a modulo by 10, so we get the last digit, that is going to be 5. Then we do it square and add it to the sum. Then once again we divide n by 5, so the remaining value is going to be 50 because this is going to be integer. And then once again we do it modulo by 10, so basically we would get value as 5, and then we will just do the square of it. So this is going to be the full logic on how we will proceed with getting the square of the sum. It's quite easy to implement and we would see that in the code. Now if we have to detect cycle, all we need to do is to keep track of all the n values that we have generated so far, and we will have to find a mechanism to quickly access that. So for every single new value of n that comes in, we would know that whether we have already visited this value or not. And for that, best way is to move forward by using a hash set. So the idea is that we would have a hash set that would keep store of all the different unique n values that we have found so far. And there can be two scenarios. Whenever a new value of n is being found out, either it could already be existed value of n, and which means we found a loop, so we can check that using hash set in big O of one time, or the given value of n could be 1. If either of this cases happen, then we simply get out of the loop and we return whatever the subsequent value of n we found. So that's quite straightforward. Now if we see time and space complexity, in this case time complexity is going to be big O of n because we are simply iterating over given input n once. Now space complexity is also going to be big O of n because we are using this additional hash set to calculate all the possible values of n. But overall this is a decent solution and a very easy problem. So now let's quickly see the coding solution in this case. So the coding solution is actually quite straightforward. First of all, we are going to initialize a variable called scene numbers, and this is going to be a hash set that we are going to be using to keep track of all the numbers we have visited to make sure are we in a cycle or not. Then we are simply going to have a while loop where we are checking that while the given n is not equal to 1 and the current number is not present in the hash set of scene numbers that we have seen. If that is the case, first of all, we are going to add the new unique entry to the scene numbers hash set, and then we are going to have a helper method called get sum of squares and pass in the value n. Now let's understand this method, the helper method. This is simply going to return an integer value and we are checking that current sum is equal to 0. Now while the given n is greater than 0, we are going to start breaking the given value n based on digit by digit by doing a modulo of 10, and we are going to add the square of that particular digit and add it to the existing sum, and then we are going to divide the current n by value 10. And notice, because n is integer, so all the fractional values would be eliminated and we are only dealing with raw integers. Now in the end we simply need to return the sum once we are getting out of the loop, and then based on this sum value we would populate our n and keep on repeating the process. Now the moment we get out of the loop, there can only be two conditions: either the given n is equal to 1, or we found a scenario where the number was already present in the scene numbers. So in either case we simply need to determine that whether if the n is equal to 1 we can return true, if n is not equal to 1 we can return false, and this would be our boolean response. So let's try to run our code. Seems like the solution is working beautifully. Let's submit this code, and our code beats a lot of other solutions, which is pretty good. Now we could do some work in terms of space complexity. Now because we are using an additional hash set, we are not the best in terms of space complexity, but there can be ways to improve upon them. Let me know in the comments if you want to see the improved solutions, and maybe I can put it in the GitHub repository. Meanwhile, this solution is present in our GitHub repository, so you can go ahead and check it out from there. Thank you. The LeetCode problem we are going to solve now is called +1. We can see that this one is a LeetCode easy problem and also a very well-liked problem. Basically, we are given a large integer that is being represented in an array sense and represented as digits, where every single value inside the digit represents that particular position. So now we need to just simply add 1 to this given array and return the new value in the form of the array. So without reading all of this, let's just try to understand it normally. Let's say that we are given an input. Basically, originally we are supposed to be given value 9523, but this is given in the form of an array. Now we need to do +1, so basically this value would become 9524, and this we need to return as the array. So we are going to once again going to create an array, and we are going to return 9524, and this is the answer that we will have to return. Same way, if these are the digits we are given, we are simply going to return 1002, but in the form of an array. Now the thing is, when we are dealing with any value that contains 9, then we will have to work about the carry, because we are adding one value to it. So if this is the value, we know adding 1 would yield the value as 10000. So once again, this is also going to be the array that we are going to have to return. But now notice that because these were all 4 nines, this was a 4-digit character, but this became 5-digit answer. So we will have to return an array with 5 entries, and this is the only edge case where we'll have to do something. Now logically, if you are ever going to be presented with this question, you are simply going to use the most basic math of addition and subtraction. So you are going to take whatever the value that we are given, that let's say that we are given value 123, you are going to start traversing from right to left, and in this fashion first you will take the value. If this value is not 9, then we can simply just add one value to it and return the answer. So in this case, since this 3 is not 9, so we can make it as 4 and then return the array as it is. So we are only changing the one index value. Let's say that we are given a value something like 1, 2 and 9. Now in this case, we know that this is a value 9. The moment we identify that there is a 9, we are going to change this to 0, and we are going to have to add 1 to this particular value and keep on repeating the same process. So basically in this case we would have considered this to become 0, and now for this remaining portion 1 and 2, we can once again repeat the same operation, that we will have to add one value to it. So in this case, for this 1 and 2, this is going to be added with one more value, and since this is not 9, so basically we are going to mark this value as 3 and then return the answer as it is. Now the only problem is if we identify for some reason that all the given characters are 9, then in this case what is going to happen? First we will try to add 1 over here. So then basically this would become 0 because this was 9. So we will have a value like this, where currently this is 9, this is 9 and this is 0, but this 9 also has value 1 that we will have to carry over. After the same operation, once again this would become 0, this would become 0, and we would have 1 carryover above this 9. Once again in the next iteration all of these 3 would have become 0. All of these 3 would have become 0, and we would still have one more carry that we are going to add in a newly created value. So the simple algorithm that we can create is that we will start iterating starting from right to left. If we identify that value does not contain 9, we simply do +1 and return the array as it is. For some reason, if we find that the value does contain 9, we are simply going to mark that index position as 0, and once again repeat the same operation for the remainder of the array of adding value 1, and keep on repeating the same process. For some reason we end or we go through the entire array and we identify that we are at the end of the loop, then we simply need to create one more array that is going to be the size one size greater than the previous digits array that we were given, and we are going to initialize first value as 1 and all the other values as 0 and return that as the answer. So this is the whole solution. Now this is not any data structure or any problem that we are using, so it is going to run in big of one constant time constant space complexity. Now in terms of time complexity, this is going to be dependent on the total number of digits that are present, so this is still going to be big of n, but it's not that much. It's a very simple problem, and now let's quickly see the coding solution for this one. So the coding solution is quite straightforward. All we need to do is just iterate over all the digits from left to right, and we are going to have a for loop to do exactly that. And then we are going to check that if the given digit is less than 9, we can simply increment the digit and return the digits array as it is. If that is not the case, if it is 9, then we will have to turn it to 0 and repeat the same process for subsequent digits, moving from right to left fashion. Now in case if all the digits were 9 that we find out, then we simply need to have a new array called new digits that is going to be one character longer or one array space longer than the original digits array that we were given, and we are going to mark that value as 1 because that is going to be the most significant bit, and all the other ones are going to be 0 by default, and then we can simply return the new digits array. So this is the whole solution. Let's try to run this code. Okay, seems like our solution is working as expected. Let's submit this code. And our code runs beautifully, beats 100% of all these solutions. That is because it's a very simple problem. The coding solution is present in our GitHub repository, so feel free to go ahead and check it out from there. Thank you. So the LeetCode problem we are going to solve now is called power of x to the power n. Now this one is a LeetCode medium problem and also a very well liked problem, but let's understand the problem statement. Basically we want to implement a power of x to the power of n kind of a function. That's it. This is the whole solution. So in the input we are given two values x and n, where x defines any integer. So let's say the value is given 2, and n would define the power that we need to generate. So let's say given n is equal to 4. So in this case we will have to return 2 to the power 4. So this is basically going to mean that 2 multiplied by 2 multiplied by 2 multiplied by 2. So basically this turns out to be 16, and this is what we need to return. Now for different kinds of input, it could be possible that the given value of n could also be negative as well. So if the given value of n is negative, then simply let's say that we are given the value 2 to the power minus 4. So in this case we can still perform the same operation, but basically we are just doing 1 divided by 2 to the power 4. So this is going to be 1 divided by 16, and I don't know what is the decimal value, but it's something like 0.06 or something like that. So this is what we need to return. Okay, so let's try to see that what is the most simplest approach to solve this problem. We know that we are given a value of n. It could be positive or negative. Let's consider those scenarios later. But let's say that value of n is given 5 and we are given the value of x. So let's say x is given 2. We can simply run a for loop that while n is greater than 0, basically we would keep on reducing the value of n one by one and multiplying the value of x by whatever the initial value of x we are given. So let's say currently x is equal to 2. During the first iteration we are going to do 2 multiplied by 2 and the value of n is going to be 4, then 3, then 2, then 1, and so on and so forth. And in the end we can return this value as 32 as the answer. This solution would work as expected, no issues with this. Now what is going to be the time complexity? The time complexity is going to be big O of the total number of n that is currently present, and which is a fair enough time complexity. It's not that complicated. But the thing is, we want to make improvements to it and we want to make this faster and better solution. That for any given value of x, let's say the value of x to the power n that we are trying to calculate, we can also write this value in x square and then we do n divided by 2, because if we do LHS with RHS, then basically x would become x multiplied by 2 multiplied by n divided by 2. So this is also going to be x to the power n, right? But logically we can come up with this solution. Now notice that by squaring the x with itself, we are reducing the value of n by 2 and we can keep on repeating this operation every single time. So in that case the solution would run in big of logarithmic of n time complexity. Now let me give you an example on what I mean. Let's take our scenario where given x is equal to 2 and we're given n, the value of n is equal to 4. We know that 2 to the power 4 would become 16, but let's try to use my formula. So in this case for 2 to the power 4 we can say that 2 square, and then we can also do like on top of it, here the value is 4, so 4 divided by 2, so this is going to be 2 as well. 4 divided by 2. I hope you understood. Now if we do that, we know 2 square is going to be 4 and this value is going to be 2, so basically this is going to be 16 and we can return this as the answer. Now notice in this case all we had to do is just do this one iteration once. We did not have to do 2 multiplied by 2 multiplied by 2 multiplied by 2. So this is a much better solution, but of course it comes with an additional cost on itself. Now let's try to think that how we can take care of negative scenarios. So if the given value of n is going to be negative value, once again same method can apply, but in this case if 2 to the power of negative 4, then we need to do 1 divided by 2 to the power 4. So in this case we will do 1 divided by 2 to the power 2 and then on top of it it's going to be 2. So once again the same set of steps are going to be done. The only thing is for negative value of n, we would change the value of given x to 1 divided by x. So I hope that also makes sense. Now there is another scenario that we did not consider, and that is that so far we consider this value of n to be an even value. So that's why doing like this operation of n divided by 2 was easy, like this operation. But what if this was an odd value? So if let's say for some reason we are given x to the power 5, so in this case we can also treat this as x multiplied by x to the power 4. So in this case we would just first multiply it with the current value of x, and then we would have an even value of n, and then we would just simply return the same logic. So this is going to be x multiplied by x square and square of it. So yeah, that's the whole point. Now there is also one more last final edge case, and I know you all must be done with all the edge cases, but if the given value of n is equal to 0, then anything to the power 0 is always going to be 1. So this is the standard thing, so we can just directly create a case and return that if the given n is equal to 0, we can directly return value as 1. So let's do a quick recap. We are basically going to do x to the power of n as x square and n divided by 2. If the given value of n is odd, then we are going to do x multiplied by x square and n divided by 2. If the given value of n is negative, then we are going to first convert x is equal to 1 divided by x. That's it. So this is the whole solution. It works as expected. Time complexity, as mentioned, it's going to be big O of log n, which is exceptionally good. Space complexity, apart from storing a couple of variables, we are not storing much, so it's not going to be that expensive. And now let's see the coding solution. So the coding solution is going to be quite straightforward. First, we are going to handle the base case where if the given value is equal to 0, then anything to the power of 0 is going to be 1. So we can quickly return that. Now, if that is not the case, first thing we are going to do is to convert the given n, that is an int value, to the long value, and this is being done for some specific edge case scenarios, nothing more than that. Then we are going to check that if the given n is equal to negative, we will first have to convert n to positive, and we will also have to replace the value of x with 1 divided by x. So basically we are going to be treating n as positive every single time, no matter what the value has been given, but we will just update the value of the given x. Now we are going to create a variable called double result and current product, and this is to store the total results and the appropriate result that we need to return. Okay, now we are going to use our logarithmic function where for as long as n is greater than 0, we are going to check that what is going to be the modulo of n by 2. If the value is 1, which means the given n is an odd number, so we are just going to do result multiplied by current product once. So that way basically we are going to be taking care of treating n is equal to even numbers for the subsequent values. Then we are going to be multiplying the current product with the current product, so basically square the base and then divide the value of n by 2. So at every single step we are making the value of n, turning it into half, and then doing the multiplication. So and then in the end we can simply return the result. So let's quickly try to run this code. Okay, seems like our solution is working as expected. Let's submit this code. And our code beats 100% of all the other solutions, and that is because we are solving this problem in big O of log and time, which is exceptional, and we are also beating a lot of other solution in terms of memory, and that's because we are just doing things efficiently. So once again, the coding solution is present in our GitHub repository. Feel free to go and check it out from there. Thank you. The coding solution we are going to solve now is called multiply strings, and we can see that this one is a LeetCode medium problem and also a very well-liked problem. Now in this case we are given two integer nums1 and nums2, but they are represented as a string, and we need to return the product of num1 and num2, which also needs to be represented as a string. Now in this case we cannot use built-in library that converts string to integer and then just do the multiplication on its own. So we'll have to find a clever way to do it, and the logical way is very straightforward. Basically we are just going to apply the same technique we learned sometime in the grade 3rd or 4th. Let's say that if I tell you that I have this number 24 and 7 and I need to do multiplication of these two numbers, what is going to be the simplest logic? So in this case 4 multiplied by 27 is going to be 28, so I'm going to use 8 and the carry is going to be 2. Then once again 2 multiplied by 7 is going to be 14. 14 plus 2 is going to be 16, so I'm going to be storing this value, and this is the multiplication result. Let's try to up the ante and let's try to do 12 multiplied by 13, right? In this case we are going to do the multiplication in 2 steps, and first step is going to be multiplying this 3 with this 2 and 1, and then next step would be multiplying this 1 with this 1 and 2, and then storing the result. Now notice every single time we move one digit to the left, we are going to add a 0, subsequent 0 as well. So let's do that. So this is going to be 6 and this is going to be 3. Okay, now we will have to multiply 1 with this 12, but actually we are multiplying 10, so we are going to be adding 1 0 over here, and then this is going to be 2 and this is going to be 1, and we are going to do the sum of these two values. So this is going to be this 156, and this is the result. So basically this is the whole idea of how we can multiply multiple digits, or like 2 digits that contains multiple digits. Number one thing is we need to start from the rightmost position. Now starting from the rightmost position, we are going to take a digit like in nums1 or no nums2. Let's say that for nums2 we took one digit, that is going to be this 3. We are going to take this digit and multiply with every single value of this nums1. Okay, so we can do that. Next thing is we are going to store this value somewhere that where it needs to make appropriate sense, and this appropriate sense comes from two portions. First one is, number one, depending on the index position we can determine that where this value should stay. Now let's come back to our computer based solution. Number one thing is, if we are given two digits nums1 and nums2, we need to store them somewhere, and the logic we are going to apply is that we are going to be storing them in an array. Now the maximum length of this array can only be the total length of the sums of digits n1 and n2. So we can generate an array like that, and I don't want to get into mathematical explanation on why that is the case, but that is the case, trust me on this. So let's say you generate an array that is going to be storing the result. Now after doing that, we'll have to do the tedious operation of storing the result for every single value, but we don't need to do one by one. We'll need to figure out what is going to be the appropriate space where we can directly store the results. So let's say that this is going to be 3 multiplied by 2. So we know that we'll have to store 6 somewhere in this array, but where the 6 is going to lie, that is going to be sum of the index positions of these two values. So let's say the index position over here is 0, 1, 2 and 3. Now the index position for this one is going to be 1, and the index position for this one is also going to be 1. So 1 plus 1 is going to be 2. So we need to store this value in I index plus j index plus 1, this value. So we store it over here, and if there were to be a carry, which is not in this case, well, let's say instead of this being 12, what if this value was 16? So in this case we would have stored 8 over here, and then there would have been a carry, and that carry would have been stored one step before that. So this is where we would take their carry in, and then once again repeat the same operation for these two values and find the appropriate index position to insert that value like this. So the multiplication is going to be stored at I plus j plus 1 location. I just explained why. And then carry is going to be stored at I plus jth location, because that is going to be one location lesser than the previous location. Now the question is how we are going to convert all of this string into numbers. So we cannot use directly parse int method, but we can do it at the character level. So at a character level we can just subtract the value from 0, and then whatever subsequent values we can actually convert that into integer. So I'll show you in the code on how it's done. So now let's see that what are the things we have. Number one, we have the way to convert nums1 and nums2 into integers. So let's say we would have values like this. Next thing is we are going to have a result array where we are going to be storing all the results of all the calculated values. And last thing is we are going to apply the common method of multiplying all the values, or like every digit by digit. So taking in one digit and multiplying with all the other digits, and once again repeating the same operation for all the remaining ones, taking care of the carry and storing them in the appropriate position inside the result array. And that we are going to be doing by doing I plus j plus 1 and I plus j for the carry. Okay, so I hope this explanation makes sense. Multiplication, it's quite straightforward. We are just going to do it the same way we have been doing since second grade, and that is to take care of all the values and then take care of the carry, and whatever the values we can store it in the answer. This solution would work perfectly well. And in the end there is going to be one last thing that we need to do, because we have the result being stored inside an array. We will have to convert this array back to string, and which we can do it using string builder, or there are many inbuilt methods that can do it, and we are allowed to do it. And lastly we need to convert it into toString and return that as the answer. So this is the whole solution. This would run in big O of m multiplied by n time complexity, where m is the total number of digits present in nums1 and n is the total number of digits present in n2, because we are multiplying all the digits with all the other digits. There is no faster way to do it apart from this, and it's acceptable because that is what the question demands. And in terms of space complexity, because we are using an additional array to store all the values, this is going to be big O of n plus m, where once again n is the total number of digits for n1 and m is the total number of digits for nums2, and this is an acceptable solution. Now personally, if someone asks this question in an interview, I don't think like it's a very valid question to begin with, but it's a popular question, and sometimes interviewer like to throw some curveballs at you. So hopefully you can tackle them just as easily as I explained. But overall, now let's move on to the coding solution for this one. Now the coding solution is not the most straightforward one, even though the problem is very simple. So let's walk through the coding solution. First, we are going to check for an edge case that either num1 or num2 is equal to 0. We can simply return 0. If that is not the case, we are going to initialize our result array that is going to be of the combined length of num1 plus num2, and then we are going to iterate over every single I and j combinations. So we are going to use two for loops to iterate over all the numbers. Now notice that we are going in reverse. So we are going from rightmost position to the leftmost position. Now for every single character, we are going to multiply both, like we are going to multiply digit by digit. And even though we cannot use directly parse int mechanism, we can still convert any particular string value to appropriate integer value by doing this operation at the character level. And then we are going to multiply both of these two digits. After that, important thing is to find appropriate position inside the result array to store that product. And we are also going to need to store the high value. That is where we are going to be calculating the carry. After that, will add the multiplication result to the current position, and also handle if there exists any query or sorry any carry. And then we are going to set the current position to the remainder value of the result position low, and also divide it by 10 to find the high position value. So we can work with appropriate next values that are going to be coming in. Then we'll need to convert this array, result array, into a string, which is quite straightforward. We are just going to use the string builder function, and then we can check that if the return the product value, if that is equal to 0, we can simply return 0. If that is not the case, we'll just convert it to the toString and return whatever the value it is as it is. So let's try to run this code. Okay, seems like it's working as expected. Let's submit this code. And our code runs beautifully, beats most of the other solutions, which is very good. Also really good in terms of space complexity as well. So once again, the coding solution is present in our GitHub repository. Feel free to go and check it out from there. Thank you. Hello friends, hope you are having a fantastic day today. So now we are going to do an awesome LeetCode problem called detect squares, and we can see that this one is a LeetCode medium problem, and also not very well like problem, because it's like quite complicated to understand, but I really found this problem quite fascinating. So let's try to work on this. Basically, we are given a stream of points on an XY or two-dimensional plane, and we need to design an algorithm that basically does two things. First, it adds the new points that we are getting of stream of XY plane data structure in, like basically storing them somewhere in a type of data structure, and duplicated endpoints are allowed, and they should be treated as different endpoints. So we'll have to keep track of the frequency of any particular endpoint at any given moment. Second thing is, given the query point, we might be needed to implement a method called counts, where we are given a point, xy point, where basically we need to determine that out of all the points that we have added so far, based on the given counts point, are we able to generate any squares? And if we can, we need to determine that what are the total number of squares we are able to make using that particular point and all the other previously points that we have received. So basically we need to implement a detect square class, and we need to have two methods in it. First one is add, that basically adds a point, and second one is count, that returns that how many number of squares that we have been able to generate. Now let's try to understand this with an example. typically we would be given an input like this, where first we are initializing the detect square class, and then we are adding bunch of the values, and we are also at random instances asking for a count of total number of squares that we have been able to detect, and these are the endpoints that we are adding. So now let's try to see how it looks like visually. So basically in this example, first we initialize this detect squares, then we add three values. So those three values are 1 1 1 3 and 3 1. So they are over here 1 1 1 3 and 3 1, only these three values. Okay, and at the same time we also come up with a count mechanism, where we are trying to check that does there exist any square from this 3 1 endpoint. So basically from this particular endpoint, are we able to generate any squares? Now notice that at this moment in this method we only have these 3 points, so we are not able to generate a square at the moment, so we will return 0 for that count method. But subsequently we add one more point, that is this 3 3, and which is defined over here, and after that once again we ask the same question of generating a count, and to which we can notice that now we are able to generate a square. And a square is simple, that every single edge should have the same length and they should be perpendicular to each other. So in this case each of this has a length 2, and they are perpendicular to each other like x and y axis. So that's why this is a square that we can form using this 3 1 point. So in this case we would return 1 as the answer. And we could have a case where, let's say, next value we are trying to add is once again 3 3, so we would have one more point over here, and then we are being asked to check that are we able to detect any squares using this 3 1 endpoint. So now in this case we can generate two squares. First square looks like this, and second square looks like the other previous endpoints. So basically in this case we would have returned 2, but you get the point that what we are trying to generate. Now, understanding this problem is actually quite complicated. How do logically we can make the solution work basically, and then we would try to understand that how can we tackle of implementing add method, and how can we tackle implementing the count method in the most efficient manner. Now let's try to visually understand the solution approach. We are given these 4 points. We are trying to determine that how many squares we are able to generate using this 3 1 endpoint. Number one thing that we are going to do is to check that do we have any other points that are common with x endpoint values. So in this case we can find that there exists a value 3 3 that is different from this point, because we also have an endpoint called 3 1 that is currently plotted, but we cannot use the same endpoint in this case. So let's say that we want to find a value that has x but a different y. Okay, so we find a corresponding value 3 3. Now we know that these two are going to be in a straight line. Now if there were to exist another value that can generate a square, basically it has to be of the same edge length as this one, so it has to have the value 2 as the edge length of it. Okay, now we have one of the edges for the square. What would it allow us to generate the square? Number one thing is we can iterate over all the other remaining points and try to see that what are the different points we have, and are we able to generate a square from that or not. But in this case we would have to take a look at all the different three remaining sides. That is going to be an expensive operation. Second approach we can do it is that based on these two endpoints we can determine that what are the endpoints we are going to need, because we already have the distance 2 in order to generate a square. And we know for a fact that if, let's say, that on an empty graph we only have the values 3 3 and 3 1, and we are being told that this is one of the side of your square, then other side of the square has to live somewhere over here or over here, where the distance has to be 2 in either case. And let me explain what I mean, because we can only generate a square like this, or we can generate a square like this, because this is a common edge. This has to live there for sure, and we know that this distance has to be 2, and this distance also has to be 2 in order for a square to exist. So what are the potential endpoints? We know that this is 3 1 and this is 3 3. So if there has to be a square with value 2 possible, then that value is going to be, so this value would have become where we are adding the x coordinate to with value 2. So basically this would have become 5 and 3, and this would have become basically 5 and 1. If let's say we had this endpoint present, we could have generated a square, because notice that the difference would have been 2 on each side, and this has to be 2 because of this. Or second option is that we could have on the other side, so that is going to be x minus 2 values for both of them, because y coordinate is going to remain constant because we are aligning our match based on the y coordinate. So this value would become basically 1 and 3, and this value would become 1 and 1. And we know that now we already had one side that was 3 3 and another side that was 3 1. Potential two values we found is either 5 3 and 5 1, or 1 3 and 1 1. So now the thing that we need to do is to check that amongst the added endpoints, do we have either these two entries or these two entries. It's not like if we have 1 3 and 5 3 it would work. No, it would not work. It has to be pair of 1 3 and 1 1, or pair of 5 3 and 5 1. And in this case we know from the input that we have a pair 1 3 and 1 1, and if we are able to find these endpoints, basically we are able to generate a square. So we can just update that value. And it could be possible that if we had this point, let's say 1 3 two times and 1 1 two times, then in this case we would have generated 2 multiplied by 2, so in total 4 squares. If we only had this like 2 times and this value maybe just once, so in this case we would have generated 2 multiplied by 1, because of the number of occurrences, only 2 squares. So we will have to keep track of the frequency of endpoint as well, in order to determine that what is going to be the fastest solution. So now let's come back to our original ask. We basically were given a data structure where sequentially we are adding the values. Now in order to add the values, what are the things that we need to take care or we need to understand? Number one, we need a quick way to look up whether any particular x value, x coordinate exists or not. And why are we considering? Same can be said for the y coordinate. I'm just taking x because it logically makes sense. Why? Because remember, in this case we were able to quickly identify this endpoint, and then we wanted to check corresponding values. So corresponding values would have been like 5 3 and 5 1, or 1 1 and 1 3. So in this case we were able to checking based on the x endpoints. That is number one thing. Second thing is, we also need to store appropriate y coordinate in accordance with the x coordinate, because there are pairs being present for x y pair. And third thing is, we need to know the frequency of any particular endpoint. So if let's say this 1 3 was present 2 times, I wanted to know this quickly. So what data structure comes to your mind in order to store this information that can fulfill all of this? Number one, if we are trying to store x and y, we could have used something like hash map. But in this case, apart from storing x and y, we also need to store the frequency as well. We can still use hash map, but this is going to be like a slightly complicated hash map, because number one, we are going to have a hash map where we need to have key value pairs. So we are going to have key and value combinations. As key, we would treat the x coordinate values. So let's say that currently first we had the value 1 1, we would have added 1 over here, and as its appropriate value we are also going to store one more hash map, a mini hash map within hash map, and that too is going to run basically the same way. It is going to have a key vault pair of its own, where the key is going to be the y coordinate. So basically this is going to be value 1, and the value is going to be the frequency of y coordinates occurrence, because we already have the frequency of x coordinates occurrence. We only need to keep track that how many times the same y coordinate occur for the same x coordinate. So in this case the frequency is also going to be 1 1, so we can store that information. Same way, next coordinate we are adding is going to be 1 3. So once again the key 1 is going to remain common, but as part of its value we are going to have one more entry inside this hash map, where now the value of y coordinate is going to be 3 and its frequency is going to be 1. Okay, then we are going to have one more entry where the x coordinate is going to be 3 1. So we are going to have one more entry 3, and as y coordinate the value is going to be 1 and its frequency is going to be 1. Same way we have one more value 3 3 in this case. So 3 we already have it as a key, as an input, so we would have stored over here the another value 3, that is the y coordinate, and its frequency as 1. So we are keeping track of frequency at every given instance, and for every single x coordinate we have the subsequent y coordinates and its frequencies. So it follows both of our desired needs. Now we know how to quickly add a value. If we see time complexity in this case, this would have run in nearly big O of 1 time every time, because based on the x coordinate we would be able to quickly look up and we would be able to see that what are the corresponding y coordinates in also big O of 1 time, because we are using a hash map. In terms of time, like space complexity, this would become an big O of n solution. For every combination of x and y pairs we would need to add new entries to the hash map, so we can generically just mention that this is going to be big O of n. Okay, this would be our solution for adding method, or to build this data structure. Okay, next portion of the problem is that how do we detect squares. Now notice that for the detect square method, basically we need to generate that what is going to be the count of squares, and we are given an entry point, so an xy coordinate that we are already given. We can treat this xy coordinate as one of our x1 and y1 that we are trying to working with. So we are going to be dealing with an x1 value, and we can quickly check in our hash map that whether we have any other values for this x1 that is currently present within our detect square method. So let's say that we wanted to detect that for this value 3 1 how many number of squares exist. Okay, so in this case for this 3 1 we know that the x value is 3, so we will come to our hash map and we will see that for this 3 how many corresponding xy values we have. One value we have is going to be 3 and 1, and so this is one value that we currently have present, but because it's the same x and y we cannot use this endpoint, so we'll just ignore this. Next value we have is 3 3, so next value that is currently present is going to be 3 3, and that is pretty good that we can actually use this. So now we have one endpoint is 3 1, another endpoint is 3 3, so difference between y1 and y2 is going to be 2. Now because we have this value 2, all we need to do is to add 2 to the one side of x and add 2 to the other side of x. So basically we already have this one edge 3 1 and 3 3. So now we will need to determine that plus 2 on the x side, so that is going to be 5 1 and 5 3. Do we have this pair present? And second one is 1 1 and 1 3. Do we have like this combination present? And if either of this combination is present, which again we can quickly look up because we are storing all the information in a hash map, so we can quickly look up whether 5 is present as an input or whether 1 is present as an x coordinate, and if they are present what are the corresponding y values. We can also take a look at the frequencies, and then we would basically just detect the squares and build the solution. So this is the whole solution. And if we try to understand the time complexity for basically count operation, this is slightly tricky but not that tricky, because we know that we can quickly look up the values of x coordinate for any particular entry in big O of 1 time, but for that x coordinate there can be multiple y coordinates. So in the worst case scenario we might have to iterate over all the possible y coordinates as well, because imagine, let's say that instead of this being 1 1, what if we have all of these bunch of different endpoints, and even over here we have all of these bunch of different endpoints. For every single pair we have to keep looking for the combinations of different x and y coordinates, so that would become a hassle. So the time complexity for this count method would be big O of m, where m is the total number of y coordinates present, because in the worst case we might have to iterate over all of them. So that's still relatively a good time and space complexity given how complex this question could have been. So we are trying to use the logic and power of math and some geometry to solve this problem and to not go through the brute force route. So I hope the solution made sense to you. Now let's quickly see the coding approach for this one. So the coding solution is going to be slightly complicated, but let's understand. So first we are initializing a private hash map that we are naming as points count, that we are going to be using to adding all the values. And notice that we have key as an integer and its subsequent value as another hash map. So there is a hash map within an hash map. Okay, then we are going to have a detect square method that is simply going to initialize the hash map, and then we are going to implement the add method. Now in the add method, it's quite straightforward that we are considering the value x as 0.0 and value y as 0.1. For every single x coordinate, we are initializing a new hash map if the x coordinate is not already present. And then for every single y coordinate, we are checking that if it is not present, we basically add the frequency as 1, or if it is present, we basically update the existing frequency. So if it is present like 2 times, we just add it to 3. Okay, now here comes the meat of our problem, that is the count method. Now in the count method, as an input, we are given an endpoint. So we are treating its x and y coordinates as x1 and y1. This would allow us to iterate over all the possible combinations. And we are initializing a variable called total squares that we have found so far as 0. Now the very first thing that we need to check is that does our hash map contains any other value that is on the same x coordinates as the given point x1 coordinate. If we don't have any values, we can directly return 0, that's it. But if we do have bunch of points on the x coordinate, then for each one of them we'll have to do the following, and that is that we would find that what are the subsequent y values. We will also try to see that what has been the frequency of that xy combination. We would check that if the y2 is equal to y1, which means we are at the same point that we are already given, we can ignore that. If that is not the case, we would find that what is going to be the edge length or side length by doing the subtraction of y2 minus y1, and this is going to be an absolute value. So it doesn't matter if it's like above x or below x. Overall, we are only dealing with positive integer. Then we will have to check that what are the possible values that would allow us to generate basically a square, and then we would add it to the existing list of total squares. And for that, we are using a helper method called count squares, where we are taking in x1 and y1 coordinates. We are also taking in x3 and y3 coordinates that we are trying to build, and we have the y2 and the count y2, so frequency of that coordinate. So after having all of this value in the helper method, we simply check that do we have the x3 coordinate that we were talking about and its subsequent y1 value. If we do, what has been the count frequency, and we simply multiply that to basically add the value to our total squares. And we do it for both like x1 plus side length and x1 minus side length. So this would give us both set of endpoints, and in the end we simply return total squares. Now I know the coding solution looks quite long, but if you just go and check it out our GitHub repository, you would find that this is an easier solution to understand once you know that what conceptual solution means. Let's try to run this code. Okay, seems like our solution is working beautifully. Let's submit this code. And our code beats 95% of all the other solutions, which is exceptional. And we beat 91% of all the other solutions in terms of time complexity, space complexity as well, which is also quite nice. So this is present in our GitHub repository. And I know that this solution says it's a medium solution, but in my opinion, this can be treated as a hard problem as well, because it's not quite straightforward to understand. So the LeetCode problem we are going to solve now is called single number. We can see that this one is a LeetCode easy problem and also one of the most liked problems on LeetCode. Basically, we are given a non-empty array called nums. Now every single element in this array appears twice except for this one element, and we need to find that single element that is only present just once. Now the important thing is we need to be able to find the solution in linear runtime, so big O of n runtime complexity, and using constant extra space, so using big O of 1 extra space. Now let's try to first understand a couple of examples. Suppose we are given an input array like this, then we can see that 1 appears twice and 2 appears only once. So we need to find the single number, so we can return 2 as the answer. Same way over here, if there are more entries, still we can see that 2 appears twice, 1 appear twice, 3 appear twice, and 4 appear twice. 7 only appear once, so we need to return 7 as the answer. So basically this is the problem statement. Now let's approach this problem in multiple ways. The brute force approach is going to be quite straightforward. So brute force approach is going to be quite straightforward. We first take a look at the number and then iterate over entire array to find that whether another copy of this number exists or not, and we can keep on repeating the same process over and over. So basically this is an inefficient approach, and this would yield big O of n square time complexity in the worst case scenario. Next approach is a slightly simpler approach. We can basically sort the given input array. We can find that then we can just iterate once and find the value that is only repeated just once. So this approach would be better than the brute force, but this would still run in big O of log n time complexity, so this is still not valid for us. Next approach is that we can actually use a hash map to solve this problem, hash map or hash set, and where we can just simply iterate over this given input and try to keep on adding all the entries inside the hash map. We can keep track of the frequency occurrence, and in the end we would find that the frequency for 4 is only 1, but that is also still going to run in big O of n time, but the space complexity is also going to be big O of n, so that is also not acceptable. So that brings us to the last solution we have. And now honestly, you are not expected to come up with this solution unless you are like a complete geek or a complete nerd, but let me talk about the solution. Basically we are going to use something called XOR gate in between any two numbers. Now you know that this is a bit manipulation technique, and basically we have gates like AND gate, OR gate, XOR gate, and things like that. So XOR is a very popular way whenever you are dealing with multiple entries that cancel out each other. And how it works is that this is the truth table for the XOR gate. So let's say that we are given X and Y as two separate numbers. So if both are basically 0, then we simply return 0 as the answer. If both are 1, then also we return 0 as the answer. So we only return the remaining answer if both values are not same. So if 1 is 0 and 1 is 1, so then in that case we basically return the appropriate value. Now this XOR logic applies to all the numbers as well. If we do 4 XOR with 4, then also the answer is going to be 0 because both values are same. There is also a logic that if we do 4, then do an XOR with 5, then do an XOR with 4, then once again these 4 are going to cancel out each other and we are going to end up with a result called 5. And this you can try to understand based on the X or Y truth table for numbers greater than 4. So basically I'm not going to write down the whole solution, but you can trust me on this, that this solution works as expected. And if we have, let's say that 10 different entries, let's say that A, then once again XOR of A, then once again XOR of X, then once again XOR of X, then once again XOR of B plus XOR of B, and then lastly if we have plus XOR of C. In this case all of this are going to cancel out each other and only we are going to be left with value C. And this is exactly what we are going to do in this problem. That suppose you given our nums array, the values are 1 2 3 and then 1 2 3 and then value is 4. So basically we would have a result value that is continuously going to store the values of the XOR to its previous value. And so in the result value, first we are going to do 1 XOR 2, same way then we are going to do that plus XOR 3, and if we continues to do that, eventually the repeated values are going to cancel out each other and we would only be left with the only number that is not repeated. So in this case, in the result, we would find the value 4 as the answer. And basically this is the whole solution. If we see time and space complexity, in this case, the time complexity is going to be big O of n, and the space complexity is going to be big O of 1, because we are not using any additional space apart from using a couple of variables. So this is relatively easy and simple approach to solve this problem. And once again, this is a pretty popular bit manipulation problem. So now let's quickly see the coding solution. So the coding solution is actually the smallest that I have done so far. Basically, we just initialize a variable called result, and then we iterate over every single nums that is currently present inside the nums array, and we simply do XOR operation with the existing result value. So basically all the elements that are duplicates or multiple copies of each other would cancel each other out, and only the single number would have left inside our result variable, so which we can return as the answer. So let's try to run this code. Okay, seems like our solution is working as expected. Let's submit this code. And our code beats 99.983%. So pretty much all the other solutions out there, which is exceptionally fast. It is also really good in terms of time space complexity as well. And once again, the coding solution is present on our GitHub repository. So this is the GitHub repository that I'm talking about. Now you can notice that on this repository, I have solved hundreds of LeetCode problems. These are the most popular and most important LeetCode problems of all time. You would be able to find solutions for each one of them. So all you can do is just simply search for it and you should be able to find it. Now these problems are pretty straightforward, and if you want to see that how popular any particular question is, I have created this Google sheet, where in the Google sheet I have created two sheets. First one is something I created by myself. I went over LeetCode Premium and went that how popular, how liked, and how important a question was based on how many times it was asked at different companies, and then I basically sorted them through different topics and different difficulty level, which are color coded. Then we have one other list for NeetCode 150, which is also pretty popular list out there, and I have been solving all of these problems as well. So if you are in the process of preparing for yourself for technical interviews, yeah, these two can be a good resources at your disposal, and I hope you find it useful. Links for both of them are presented at the description of this video. Hello friends, we are still not employed by a FAANG company, so let's not stop lead coding till we get there. Today we are going to work upon a lead code easy problem, number of one bits. And this is a bit manipulation problem. I know a lot of people don't like it, but it's really simple to understand. So the problem statement is pretty simple. We just need to check that in any given integer, if we represent it in binary form, how many times the one value is being repeated. So in this given example, we are given a number like this, n is equal to 1011, which is the binary representation of the decimal value 11. That we need to check that how many times this one is repeated in the given integer, and clearly over here we can see that the one is being repeated 3 times, and which is the answer of this problem. And notice that the number is represented quite long because it is showing that all the 32 bits of any integer, and all the input types would be of 32 bit, and we need to find that how many times one exists. So the first approach we are going to take is quite simple, and we are going to use a binary operator AND. Now let me show the table for AND binary operator for any given two values. We can have four possible combinations, and A and B means if the value of A and B both are 1, in only that scenario we are going to consider the value of A and B as 1. Otherwise, if there exists any single 0 or both values are 0, we would just simply put the values as 0. Using this logic, we can solve this problem really fast, and the most basic approach is we would simply run a loop 32 times, and every single time we are going to compare each element with 1 and see that if we AND the value that exists at any given location with our value 1, and if the answer is 1, we do counter plus, and after running the loop for 32, all the 32 bits, we would just simply return the value of our counter. Let me show you by an example what I'm trying to say. Suppose the input we have is 13. If we represent it in binary, it would look like, and we would have 28 zeros and the prefix. Now we will create a value, just any random variable, and we would give it as value number 1, and we will run a loop from 0 to 32, and inside the loop, for every single value, we would compare that whether this 1, we would compare it with the rightmost element in our given input array, and we would do an AND operation between these two values, and we would have a counter that we initially set it up as 0, and whenever we find that the answer of these two AND variables is actually 1, we would simply increase the counter. So for the so for the rightmost position, we would increase the value of our counter, so counter would become 1, and after we are done with this condition, we would simply do a left shift for this random operator in the for the given input. So now 1 would be shifted one position to the left, and we would again do the same operation. So this time we will do an AND operation between this 0 and 1, and the value of AND operation would be 0. So we won't update the counter, and again we would do a left shift for this one element. And again we would do an AND operation. The value we would get is 1, which means we need to update our counter. So counter becomes 2. And again we would shift our element. We do an AND operation again the value still remains 1, so we update our counter again, and we update the counter to 3, and then we would subsequently update the value of this random character to 1 bit to the left. And now notice that all the remaining bits are 0, so the AND operation will always equal to 0, so we won't update the count, and at the end of the loop we can simply return whatever value of count we found as our answer. Now this approach works perfectly fine, and this approach actually runs in big O of one time, because we only have to run the loop 32 times, which is a minimal amount of work that we have to do, and the answer would always be constant. So this is in itself pretty neat solution, but let's see if we can go one step further and we can reduce this loop counter time to less than 32. In order for us to understand the optimal solution, let's first take an example. So, say we are given a value n equals to 36. Now let's represent this value in binary, because we know that binary works like 2 to the power 5. And if we do the summation of these values in decimal terms, uh, this would become 4, and this would become 32. So 32 plus 4 becomes 36. Now the intuition behind this solution is that if we take one value lesser than 36, let's say 35, and if we represent this value in binary terms, the binary representation looks like, and notice that the first one that we encountered on our original input, the one value lesser than that has the exact opposite in terms of number of ones up until this point. That if we do a AND operation between these two values, the value we would get is like this. So notice that this one has already disappeared in the AND result of these two values. And if we repeat the same process, so now this value that we got in binary, the value is actually 32. And again, if we repeat this same operation, that we do an AND between the number by itself with one value lesser than that, we would gain a result like. So first let's represent the value number 31 in binary. And now if we do an AND operation between these two values, the answer we would get is all zeros, which exactly means that we would only run the loop the number of times one we have in our original given input. Because over here we only had 2 1 in the input, so during the first iteration of our loop we got rid of this first one, and we can see it over here. And during the second AND operation we got rid of the second one as well, and we got the answer as all zeros. So at the beginning, if we create a variable count and we originally set it up to 0, and every time in the given loop, if we just go through the loop and the value of the value of current n is not equal to 0, we just simply increase the value of count to 1. So which means that during this first iteration the value of count would be 1, and during the second iteration the value of count would be 2. And after that we found that the value of n is actually equal to 0. So we can simply break out of the loop, and when we break out of the loop we would return whatever the value of count we had found. And in this case the value of count we found is actually 2. And this solution would work perfectly fine, and this would be our optimal solution. The time complexity for this solution is also big O of 1, which is a constant time. But the thing is, the number of loop iterations that we have to go through would only be equivalent to whatever the value of 1 we are given in the original input array, and we don't have to run the loop 32 times like the previous solution. So we are actually, in our constant time solution, we are also saving a lot of time, and this would be the fastest solution we can reach into. And in terms of space complexity, we are not using any additional space, so complexity would also be constant time. And and now let's move on to coding. Thank you. So first of all, we will create a variable for count and set it up to 0. Now we simply run a loop. We will run this loop till the number is not equal to 0. And with every iteration, we will increase the value of count, and we will simply do n equal to n and n minus 1. At the end of the loop, we just return count. Looks like our solution is working. Let's try to submit the code. And yeah, submission works as expected. It's pretty efficient and neat. And let me know what do you think about this video. And if you have any more suggestions, feel free to reach out to me in the comments, and I can address them. Thank you. Bye bye. Hello friends, we are still not employed by a FAANG company, so let's not stop lead coding till we get there. Today we are going to work upon a lead code easy problem, counting bits, which in my opinion should be a lead code medium problem. Let's understand the problem statement. So basically we are given an integer n as input, and we need to return an array such that it defines that for every single value from the range of 0 all the way to whatever given n is, how many times the value 1 is repeated in its binary formation. So let's try to understand this with an example. Suppose our given input is 3. So the range from 0 to n would be 0, 1, 2, 3. And if we represent these values in binary, the representation would look like 0, 0, 1, 1, 0, 1, 1. And we need to return an answer array such which is of n plus 1 size, such that it represents that for every single value from 0 to n, how many times this bit 1 is being repeated. So now for the 0th position, we don't have any ones, so we enter the value 0. For the first position, we have one bit, so we enter as 1. Same goes for the second value, so we again add 1. And for the third value, we have two ones, so in the answer we provide as 2. And this would be our array that we would return as our answer. So let's see what are the different approaches we can take. So the first approach we can take over here is of one of the previous lead code questions that we have already solved, a number of 1 bits. And let me give you an overview of the solution we had achieved previously. So if we are given any number n is equal to 5, and if we represent it in binary, it becomes 101. And if we want to find that how many number of 1 exist in the given input, we would simply do an AND operation between the number and its one value lesser than the number of itself. So one value lesser over here would be 4, and if we represent it in binary, it becomes like this. And if we do an AND operation between these two values, the answer we get is 0, 0, 1. And this would be our first iteration. Now we would repeat the same process. So now again the number we found after doing this AND is 4, and we would do an AND operation with one value lesser than 4. So 3 would become 0, 1, 1. And if we do an AND operation between these two values, the answer we get is 0, 0, 0. And the moment we get 0 answer, we break out of the loop. And at the beginning of our loop, we would create a variable count, and only initially it would be set up to 0, and with every iteration we would increase the value of count. So during this iteration the value of count would become 1, and during this iteration the value of count would become 2, and at the end when we find that the number is actually 0, we would return whatever value of count we found as the number of ones that exist in our given input. So we found that in our given input 5, it has two number of ones. We can repeat the same formula for the given input, and let me show you how we can do it. Suppose the input we are given n is equal to 4. We need to create an array from 0 to 4, and we need to calculate that for every single value how many number of ones are present in that given input. So the answer array would be, we would need to provide that how many number of ones exist. So we can create a function called count1, and for and we can run a loop over all these values, and every single time we would pass on whatever the current value we are trying to find the count for. And whenever we run this function that uses this logic, the one that we just discussed, then we would be able to find that how many number of one exist for every single given element. And when we get the answer back, we can just simply fill in our array and return this as answer. This solution would work perfectly fine, and the time complexity for this solution would be n, because we will have to run a loop towards the entire towards all the given values, and we for every single value we would have to run this operation, count the number of ones, and this loop runs for the time being of number of ones that exist in any given input. So over here for number 5, there exist two ones, so we will have to run the loop twice. Suppose if we are given any n is equal to like this, then the loop will run 6 times. So we can say that this solution basically works in the time complexity of big O of n times log n, because in order to find this count, because in order to find number of ones, we would have to run multiple loop, we will have to run multiple iterations in this count one solution. So this is in itself a pretty efficient solution, but we need to see that if we can find a better approach and can we have an optimal solution. We can have optimal solution. Let me show you how we can achieve that. Now, in order to find the optimal solution, first let's try to understand that how the logic actually works if we want to find the number of ones in any given element. So the operation we are doing is basically we take n and n minus 1, and then we do a counter plus plus. We can represent it in a different manner. So first let's try to understand that suppose n is equal to 9. The actual calculation we are doing is n minus 1. We are doing an AND. So basically this means that after the AND operation we get the value as, and the value this comes up as 8, and we do an a plus 1. So keeping this in mind, and again if we do it for the value number 8, what we are actually going to do is we are going to, now our n is 8, so we will do n minus 1 as 7, and the answer is 0. So basically our n is 0 at this moment, and we again do plus 1 in our counter. So if we write this in other way, we can write it as that answer for the number 9 is actually whatever the answer we found for 9 and 8 plus 1. And if we go down one step further, the answer for actually this 9 and 8 is actually the answer for whatever the value of 8 we found plus 1. We can write this exact same formation as this. And if we try to calculate the value for this uh, a of 8, actually we can write it as a of 8 and 7 plus 1 for this particular value. And this actually becomes a of 0 plus 1. And we know that a of 0 is actually 0, plus 1 is 1, and this 1 is actually the value of a of 8. Now, if we replace this a of 8 over here, we can say that the a of 9 is actually a of 9 and 8 plus 1, and we know that the value of a of 9 and 8 is actually a of 8 plus 1, and we know that the value of a of 8 is actually this 1. So we can say 1 plus 1, and we can come to the conclusion that the number of ones present in value number 9 is actually 2, and which is what we are given over here, and which is what we know. And basically what we have done is we have taken this input for any single individual element, and we have actually computed the results, we have actually stored the results, and based on those results we are able to find the future values. And basically we are applying dynamic programming. We can simply calculate the solution for our entire array in just big O of n time. Let's take another example to make things more clear. Suppose our given input is equal to 6. So if we want to find the answer for 6 using the logic we found over here, we can consider this as answer for whatever we find for 6 and 5 plus 1, and the answer for 6 and 5 is actually this equals to 4. So we can write this as answer for whatever the value of 4 we got plus 1, because this turns out to be 4. And subsequently, if we calculate the value for 4, we can break it down further as, so we can write this as answer for 4 and 3 plus 1 for this portion and plus 1 for this one. The answer for 4 and 3 is actually n is equal to 0. So we get answer of 0 plus 1 plus 1. This would be our final answer for our answer for value number 6. So see over here that we have, when we get to value number 6, we would have already calculated all the values from 0 to 5. And we, since we have the answer for from 0 to 5, we will use those answers to quickly determine the answer for value number 6. And this logic enables us to get our solution in just single iteration, and this would be a better time complexity than our previously suggested algorithm. And in terms of space complexity, anyways, we have to create an answer array in order to return it as a part of the answer, because it is given as requirement uh, for the given input, that we are not using any additional space, and we can just use the same array to represent the answer and also use it as our dynamic programming solution. So space complexity would also be a big O of 1. And this is a really ideal approach. And let's move on towards the coding. So first of all, we will create an answer array and we would give it the size of n plus 1. And now we initialize the answer array of 0th value to 0. And now we just need to run a for loop. We'll start the loop from I is equal to 1 because we already calculated the value for 0. And we will run it while I is less than or equal to n. And we just have to write one line of solution, that if our answer of current I is actually equal to answer of I and I minus 1, and whatever the result of this is, we just add 1 to it. And yeah, basically after the loop we should have our answer array completely filled up and we can simply return it. So let's try to run our code. Oh, we forgot to initialize the value. Yeah, looks like our solution is working. Let's submit this. Our submission works pretty fast compared to a lot of other submissions, and as we can see that this is just a couple of lines of code that is really doing the trick. So though this is really simple to see, but in order to come up to this answer requires very strong knowledge of dynamic programming. Hope you like the explanation and the videos. Let me know if you want me to do anything else with the videos, or provide me any suggestions on how can I improve. Hello friends, we are still not employed by a FAANG company, so let's not stop lead coding till we get there. Today we are going to do a lead code easy problem, reverse bits, and this has something to do with bit manipulation. So let's understand the problem statement. Basically, we are given a 32-bit unsigned integer and we need to reverse all the bits in it. Let's consider it by an example. Suppose the value we are given n is equal to 5, and if we represent it in binary, the binary representation would be, and since the given input is 32-bit, all the other bits would be 0. Now we just need to return a new element, reverse, that looks like the exact reversal
of this binary value. So this would the so the rightmost bit on the original input would be the leftmost bit on our new variable. So the value should look like 1, 0, 1, and all the remaining zeros because this one is also 32-bit. So basically the rightmost zero would be at leftmost position in our new variable, and we need to return this. The problem statement is really easy to understand, and let's see that what could be the approaches we can take to solve this. In order to solve this problem, we are going to use bit manipulation, and specifically we are going to use two bit manipulation operators. First one is AND operator, and second one is OR operator. And let me show you by truth table what each of these operations represent, and these are the symbols to represent them. So the possible value for A and B we could have is, so for A and B, if both the values are 1, then only we consider A and B as 1. Otherwise, if there exists a single 0, we will keep their value as 0. So this would be the table for A and B. And in A or B, if there exists a single 1, we would consider the value for A or B to be 1. So if both are 0, then only we would have A or B as 0. Otherwise, the value would always be 1. Now let me show you that how can using these two operators we can calculate our solution. We are only given one thing over here, the input parameter n, and suppose our n is 5, so the values would be like this. The new variable that we are trying to determine reverse is actually unknown to us, and that will have all the values that are in reverse order for the given n. And we know one thing, that all the values in given n is actually 32 bits, not more than that. So the first intuition is that if we run a loop 32 times, and every single time we take whatever element is present in n, and if we put it in our reverse variable, so whatever element we have present in our n, we put it in the reverse variable, and then we start shifting the reverse variable one step to the left side. So at the end of the loop, our reverse variable would be exact reverse of whatever value that is present in the given n. So let's determine that what would be our algorithm. Initial value for our reverse parameter would be 0. So the entire value would be, and when I say 0, I mean that all the 32 bits would be 0 for the reverse element. Now, at the beginning of, and we would run a loop from I equals to 0 to I equals to 32. And at the beginning of our loop, we would have a condition that every time we are going to left shift the value of reverse parameter to 1 bit. So at the end, we would have rotated any value that is present over here, we would have rotated it to 32 times, and it would end up on the leftmost position. After the rotation of the value, so first of all, so inside the loop, first of all, we will rotate 1 bit to the left, and we would represent it with this symbol. Next, what we are going to do is, somehow we will have to get whatever value of n is present. We need to copy that value for that particular element and somehow put it on the subsequent position at our reverse order. So how can we do it? And we know based on our and or operators, so at any given moment the possible value for n would be either 0 or 1, and we want to copy whatever value of n exists in our reverse parameter, a reverse variable. So if we do an n and 1 operation, then this would specify, and this would provide us with whatever value of n there exists. So suppose if the value of n exists as 0, and if we do an AND operation with 0 and 1, the result we would get is 0. If the value of n exists as 1, and if we do an operation 1 and 1, the value we would get is 1. So this is how we can get the exact value of 1 that is present, exact value of n that is present. And once we calculate this value, that n and 1, we need to put this value in our reverse variable. But the thing is, in our reverse variable, all the values are initially set it up to 0. So all the values are 0, and the potential value of n and 1 operation could be either 0 or it could be 1. And whatever we get over here, we need to transfer it to our reverse variable. And the way we can do it is, if we simply do whatever element is present at our reverse variable, and if we do an OR operation with whatever the answer we get from n and 1, we would be able to put the exact value that was present at n at any given moment. So the operation that we are going to do is, current value of reverse we have with, and we would be ORing that with n and 1. And suppose initially, so if the value of n is equal to 0, the answer after this operation would become 0, and we know that the value of reverse is initially set to 0. So we would be doing 0 or 0, and the answer we would get is 0, and we would shift it to our reverse. And at every single iteration, we are going to do a left shift on the reverse parameter. So whatever value we set up at the end of the 32 iterations, it would end up over here. And so we are taking care of the value of reverse parameter by shifting them one parameter left. But we also need to shift the values of given n one parameter, one bit to the right side, because we need to calculate every single value of n. So suppose the value of n is like 0, 1, and then bunch of zeros, and then 1. And this comes out to be the whole 32 bits. We need to calculate every single value of n that is present, and we need to put it in the reverse order. So at the beginning of our loop, we will calculate this value. We would put it in our reverse loop, and once that is done, this value would be stored over here initially in our reverse variable. But we know that we are doing a left shift operation on our reverse variable. So eventually the value will keep on transporting on the left side, and it would end up at the first position, which is what we want. But the thing is, on the on the given input, we need to do a right shift operation. So we keep on eliminating the values that we have already calculated, and we are eventually, when we come to the end of the 32nd bit, we would come to this value. So 31st bit would become this value, and this value would be entered at the second position reverse variable. So I hope this makes things clear. I know it's a little bit tricky to understand, but once you will do an example by yourself with this expression, that reverse, the value of reverse is actually the reverse we currently have, or n and 1. And after this, we would be able to copy whatever value of n we have to our reverse for that particular bit. And then it's just a matter of shifting the values of reverse on the left side and shifting the value of n on the right side. And at the end of the loop, we can simply return the value of reverse variable, and this would be our answer. So now let's calculate the time complexity for this approach. Basically, the time complexity would be big O of 1, because the only work we need to do is we need to run a for loop for 32 times, and that can be done in constant time. And even for the space complexity, we can complete the entire iteration in just constant time, because we are not using any additional data. We are just using couple of parameters to store some values, and this would be a very fast solution, and it's really simple to understand. But the thing is, we need to come up with a little bit of logic, and we need to have a little bit of understanding of the bit manipulation operators. And now let's move on to coding. So first of all, we will create a variable reverse and initialize it to 0. Now we will run a for loop. Inside the for loop, we will first of all do a left shift on reverse. Then we will apply our logic to calculate the value of n to reverse. So we will do reverse or with n and 1. And now we just do a right shift 1 bit for the variable n. And after the loop, we simply return the value of reverse. Let's try to run this code. Yeah, looks like our solution is working. Let's try to submit it. And yeah, our submission works actually 100% faster than all the other submissions, but this is not true. This is because the solution runs in the constant time. And hope you like the video. Let me know what kind of videos you want me to do next, and if you have any suggestions regarding my videos, feel free to let me know so I can improve upon them. Our aim is to clear the FAANG, and we are not going to stop till we clear FAANG interviews. Thank you. Bye. Hello friends, we are still not employed by a FAANG company, so let's not stop lead coding till we get there. Today we are going to work upon a lead code easy problem, missing number, and let's understand the problem statement. Basically, we are given an array of numbers containing n distinct numbers in the range of 0 to n, and we need to return that there is one number that is missing, and we need to return the missing number. So if we take the first example, the range we are given is 0, 1, 2, and 3. But when we see the actual input of nums, in the input we only have 3, 0, and 1. That if we start cancelling out the numbers that are present in nums and also present in our given range, 0 can be cancelled out, 1 can be cancelled out, and 3 also can be cancelled out. But the value number 2 is present in our range but not in the given input. So we would simply return the value 2 as not being present, and 2 being the missing number. So there can be multiple approaches on how we can solve this problem. Okay, and we would try to keep in mind with this follow-up as well, and we will try to solve this problem in big O of 1 space complexity and big O of n runtime complexity. So the first two trivial approaches we have in our mind is first one, that if we sort the input array, we can clearly we can solve this problem easily. But the issue with the sorting approach would be that the runtime complexity would be n log n, because we need to do sorting first, and that takes n log n time. Second approach is to use a hash set, and we would keep on storing all the values of nums input in the hash set, and then we would iterate with the range loop and go over hash set to see if the value exists in the hash set of not, or not. And eventually we would find a value that exists in range but does not exist in hash set, and that would be our solution. And the good thing about hash set approach is that runtime complexity would be big O of n, and but the issue comes for the space complexity, and the space complexity for this approach would also be big O of n. which is not what we want. So let's see what would be the optimal solution. And I would be showing two optimal solutions in this coding problem. So our first optimal approach is actually pretty simple. Basically, we are given two items. First one is range, that is from 0 all the way up to n. And second one is nums input array, where the values are 0 all the way up to n, but one of the value is missing, and we need to find this missing value. So the most simple approach to do is we run a for loop on this range parameter, and for every single value in the given input from 0 all the way up to n, we simply do an addition of all the values. We store the result of all the elements in the range in a parameter called range sum, and we would find some value over here. And again, we repeat the same process, but this time for nums. So we do the sum of all the elements in the num with another for loop. We store the result of sum in a new parameter called num sum. You can put any name. This is just randomly something for taking the name. And then when we do a difference between range sum and this number sum, the difference would actually be the missing number. And this way we would be able to find the solution pretty quickly. Let's take it by a quick example. So clearly we can see that this value 1 is missing. So the sum of all the elements over here would be 10, and the sum of all the elements over here would be 9. So if we simply do 10 minus 9, we would find the value 1, which is the missing number. And this solution is pretty simple to do, and the time complexity would be big O of n, because we are just simply running two for loops separately. So we are not doing much work in terms of time complexity. And for the space complexity, other than storing the value for just couple of parameters, we are not consuming any additional space. So the space complexity would be constant. And this is an optimal approach that we are asked as a follow-up in our original input. For the second optimal solution, we are going to use bit manipulation. And specifically, we are going to use XOR operator. So if you don't know what XOR operator is, let me give you a quick tutorial on what each value is being represented when it gets XORed with some other value. We can only have four possible values for A and B because all the values in computer system are represented as binaries. Now in the XOR, if both values are 0, we consider the value as 0. If any one value is 1, we consider the A XOR B as 1. Same goes for this one. And if both values are 1, we again consider A XOR B as 0. Now, let's see that using this logic, how can we find the missing number? So, now consider this property that for any given value n, if we XOR n with itself, the answer we would get is actually 0. And let me show you what I mean by that. Suppose our current n is actually 6. And now let's represent this in binary. And now let's try to do n XOR n. And this is the symbol for XOR in in programming language. So if we do the result, uh, 0 0 is 0, 1 1 is 0, and 1 1 is again 0. So if we XOR two values together, the answer we get is actually 0. But if we XOR, so suppose if we XOR the values like 6 XOR 6 XOR 3, the answer we would get is actually the value by itself. So because 6 XOR 6 would be 0. And now let's try to XOR 3 with this given 0. So the binary representation for 3 is equal to 0, 1, 1. And now when we try to XOR these two values, 0 and 3, the answer we would get is 0, 1, 1, which again means 3, the number that we XORed 0 with. And we also notice one more additional property over here, that whenever we XOR two values, so 6 XOR 6 XOR 3 gives the result as 3. Also, if we change the order and if we put any order like 3 XOR 6 XOR 6, this will also result in 3. And if we do like 6 XOR 3 XOR 6, this will also result in the value 3. Because order doesn't matter. If we are XORing two values by itself, both are going to eliminate themselves and their answer would be 0. So whatever is remaining would be the answer of this one. And we can repeat this for whatever number of times you want. So we can, if we do something like uh, 2 XOR 3 XOR 2 XOR 6 XOR 6 XOR 7 XOR 7. If we run this entire thing, still the answer after this would be 3, because notice that over here 2 cancels itself, 6 cancels itself, and 7 cancels itself, and only 3 is going to be remained. So now since we have established all of this, let's try to see that how can this be useful for us in this given problem. The input for our given problem is actually we are given range and we are given the input number. So suppose for an example, the range we have is 0 to 4. So 0, 1, 2, 3. Let's consider it 0 to 3. And the input parameters we have is suppose 1, 3, and 0. So notice that number 2 is missing. Now, if we were to use this XOR logic, that if we XOR all the values in the range with all the values in the nums, we would get something like this: 0 XOR 1 XOR 2 XOR 3 for this range portion. And if we XOR this with the nums input, we will get 1 XOR 3 XOR 0. And if we combine both of these, basically all the values that are same would be eliminated and would be turned to 0. So this 0 would cancel out this 0, this 1 would cancel out this 1, and this 3 would cancel out this 3. And notice that right over here we just determine that the order in which XOR happens does not matter. Everything is not right next to each other, still they will cancel out each other, and at the end we are only going to be remained with the value that is not at all present in this nums input. So in the nums input we don't have the value number 2 present, so the result of range XOR nums would actually give us the value 2. And the result 2, we can simply return it, and this would be our solution. So this is a very neat, very unique solution, and because we have the knowledge of XOR, we are able to come up to this result. And if we use this if we use this in any interview, this clearly shows that you have very sound knowledge of computer concepts, and you know how to apply them when they seem fit. This would definitely give you a very extra, very sharp edge over all the other candidates. And let's do the complexity analysis. So for the time complexity, we are actually doing everything in just the single loop, for one loop for range and one loop for nums. So the time complexity would actually be big O of n, and the space complexity would actually be big O of 1, because we are not using any additional space. So this would be the most optimal solution. And this is what the problem is asking us to find. Now I showed two optimal solutions, but first optimal solution is very trivial to understand. So I'm not going to code it up, and I'm only going to code up this XOR solution. So we will first of all create a variable XOR and we initialize it to 0. You can give any name. And now we will run a for loop starting from the range. So int I equal to 0 to I is less than or equal to nums dot length I plus plus. And every time we will XOR the number with itself. So now again we will run another loop, and this time we will run it for the given input array. Notice that we are only using I is less than number of length, and over here we are using less than or equal to, because in the range we have one value more than whatever the length of number is. And again we repeat the same operation, XOR with the value in the given input array. And now we will simply return whatever we found in XOR, that this would be our missing value. Let's try to run this code. Looks like our code is running. Let's try to submit it. And yeah, our solution works perfectly fine, and it's actually pretty fast and pretty efficient. And hope you like this video. I'll be posting the solution in the comments, and let me know if you have any suggestions for the videos. Yeah, let's clear FAANG together. Hello friends, we are still not employed by a FAANG company, so let's not stop lead coding till we get there. Today we are going to work upon a lead code medium problem, sum of two integers. So let's understand the problem statement. Basically, we are given two elements a and b, and we need to return the sum of two integers without using the plus or minus operator. And the problem statement is really simple. Basically, we are given two values a and b, and we need to return the sum of a plus b equals to in this case 3, but without using the plus operator. So let's see how can we do that. We are going to use 2-bit manipulation operators. First one is something called XOR or exclusive OR, and second one is AND. So let me show you what each of them does and what does it mean. So we will consider a table like this, where we are given the values of A and B and the value of A XOR B. Now these are binary elements, so we can the only possible values we can have for A and B is 0 and 1, and we can have four possibilities. Either both are 0 0, 0 1, 1 0, or 1 1. And the answer for A XOR B would be 0 0 is 0, 0 1 would become 1, 1 0 would also become 1, and if both are 1, we would again consider it as 0. So this is just something that we keep in our mind, and we will use it further down in our equation. Now let's see what would be the table for A and B. Now as the name suggests, A and B, we only set the value as 1 if both entries are 1. Otherwise, if there is any single 0 present, we get the answer of A and B as 0. And now let's see how can we use these two operators to find the sum of any two values for our given problem. So suppose we are given two values like this, A equals to 5 and B equals to 3. So the sum of A plus B, as we know, is 8. And let's see how these values are represented in binary. So A would be represented as 1 0 1, and B would be represented as 0 1 1. because in binary operator, the value of any element is actually done as 2 of 0, 2 of 1, 2 of 2. So this becomes 4 and this becomes 1. So 4 plus 1 equals to 5. And same over here, this is 2 and this is 1. So 2 plus 1 equals to 3. Okay, now let's try to do a summation of these two values. So 1 plus 1, we cannot do 2 over here because this is a binary representation. So we will do as 0 and we would have 1 as carry that we carry on towards the left value, and again we get 1 plus 1. So again the value becomes 0 and we have a carry that we need to consider on the left side. If we take the carry again, we get the value 0 and we will have a carry over here, and we don't have any value over here, so we can just consider this as 0 0. So with the carry the value becomes 1, and if we do the if we find the binary value for this one, this is actually 2 of 0, 2 of 1, 2 of 2 and 2 of the power 3. So the value 2 of the power 3 is actually 8, and which is our answer. So if we do the simple addition of binary values, we can also get the answer as 8. But the problem over here is that we should not be using the plus operator, so we cannot just simply add these two values. So the longer route we can take is we can try to do A X or B first, and then we would do A and B, and we would move the values to one point left. This is simply what we are going to do for the given elements until the point where we find that the values of A and B uh, as 0. So this is the broader idea of our algorithm, and let's see what I mean by that. So the value of current A is 1 0 1 and B is 0 1 1. So let's try to do A XOR B. This is the symbol for XOR in computer language. So we will simply use this one, and let's see what the value becomes. So we know that 1 1 is 0, 0 1 is 1, and 1 0 is also 1. Now we need to do the operation of A and B. We are doing this operation to find the carry value with A and B values. And because we are finding the carry values, we know that whenever we have a carry at any location, we need to move it one step on the left side. So we will again use the same logic that we will use A and B to find the carry value, and we would move it one step on the left side. So let's see what the values would be for A and B. So basically we have 1 1 over here. So that value would become 1. And notice that we are writing 1 over here and not over here because we are shifting the element on one step towards the left side. So we have 1 1 as 1. Next values we have is 1 0, sorry 0 1, and we set it up as 0, and again we have 1 0, so again we set it up as 0, and because we don't have any value over here, we shifted one value on the left. We can consider the value as 0 over here. Now we have calculated the results for A XOR B and A and B, and we have moved them towards the one step on the left. In our algorithm, this would become our new A and this would become our new B, and we would have a loop that until we get a value of B that is not 0, we would continue with this operation, and let's see where we will get. So now the values for A and B would be A would become 1 1 0 and B would become 0 0 1 0. And now let's repeat the operations again. So first we will do A XOR B, which gives us 0 1 1 becomes 0, and we will have a carry, but we will consider it later. 1 0 becomes 1, and 0 becomes 0. Now let's do A and B and shift it to 1 bit on the left side. And because we have to move it 1 bit on the left side, we will start it over here. So 0, so 0 0 becomes 0, 1 1 becomes 1, 1 0 becomes 0, and 0 becomes 0. And because we don't have any value on the rightmost part, we will consider it as 0. So again, we will assign the values as A and as B. And we notice that B is still not 0. So we will continue with our operations and we will continue with our loop. So again, let's repeat the same operation. So A mod B becomes 0, 0, again 0, again 0, and 0. So all zeros we are getting as A XOR B. And now A and B shifted one element on the left side becomes, we start one element on the one element from the rightmost element. So 0, again 0 for these two, 1 1 becomes 1, 0 0 again becomes 0, and we have one blank element on the rightmost bit, so we can consider it as 0. This becomes our new A and this becomes our new B. We notice that B is still not 0, so let's repeat the operation. And now we are going to do A XOR B equals to 0 0 0 1 0, and A and B shifted one bit on the left side. So notice that on this A value, we don't have any ones, which means that under no circumstances we can have this A and B where we get one answer, because A is always 0. So same thing applies over here, and basically this value would become all zeros, 0 0 0 0 0. And now again we assign our values. So this becomes A and this becomes B. And notice that in this scenario, B is completely 0. So we can break out of the loop. And when we break out of the loop, we can simply return the value of A. So the value of A we have found in this scenario is 0 1 0 0 0. And this is a binary number. If we were to convert it to decimal value, we can understand this as 2 of 0, 2 of 1, 2 of 2, 2 of 3, 2 raised to 3, and 2 raised to 4. So all of these values are 0, so we don't consider them. This one is 2 cube, which is 8. So we can return A as 8, and this would be our final answer. And if we see the original two values in our request, basically we had the two integers A equals to 5 and 3, and we get our answer perfectly defined over here, and we reach to this answer without using the plus operator. So this would be our solution. And now let's calculate the time complexity for the given problem. So basically, if we see the given input over here, we have a constraint that all the values are between -1000 and +1000, which means that essentially we can calculate the time in a constant time complexity, big O of 1. We don't need to calculate anything additionally, because overall the input is quite small and we can simply do it constantly. And also the space complexity would be big O of 1, because we are not using any additional space. We are just using a couple of variables to store just few values. So this is a really ideal approach. And I know that a lot of people don't like to have bit manipulation, and they simply ignore it or they hate it. And most of the times companies don't tend to ask this kind of questions, but we are preparing for FAANG. We are not preparing for some random company. And if you want a dream job, why would you compromise? So I would just suggest that go over it. It might take you like 2-3 hours to go through all the bit manipulation questions and understand the concepts. But once you are done with that, you will have an extra edge in the interview. So I would highly recommend not to skip anything and not to put anything on the chance. I will, and now let's move on to the coding and we are going to implement the solution.
So if our intention is to just submit it for the sake of submitting it and have it accepted by LeetCode, we can simply write one line of code. We can simply return a plus b, and apparently it works. Yeah, but this is not what we want. So we would be writing the complete solution that we would use in an actual interview. So first of all, we will create a while loop to see if the value of carry is actually 0 or not, and we are going to store the value of carry in the b element. So while b is not equal to 0, now we will create a variable to store the value of a, x or b. Let's name it temp, and now we will calculate carry as well. We will do a and b and shift it to one place left, shift it to one bit on the left side. And now we simply store the value of temp in a, so a becomes our temp, and as mentioned earlier, we will store the carry in b. And yeah, that's pretty much it. Once this loop runs, our solution should be stored in a, so let's return a. Let's try to run our code. Looks like our solution is working. Let's try submitting it. And yeah, our solution works pretty neatly. It's apparently 100% faster than all other solutions, but actually this is not true. All other solutions are also 100% faster because the runtime is in constant time. So hope you liked the video, and let me know in the comments if you want me to update anything in the video. Our aim is to clear FAANG interviews. I'm making these videos so I can practice for myself, and also I can spread the knowledge I have gained to other like-minded people. And yeah, see you soon.
So the lead code problem we are going to solve now is called reverse integer. Now this one is an extremely popular lead code problem and also a medium one. Basically we are given a signed 32-bit integer x and we need to return x with its digits reverse. So basically let's say that if the given x value is 1 2 3, then we need to return x is equal to 3 2 1. Same way, if we are given a negative number, let's say x is equal to minus 4 3 5, then once again we need to return as minus, then 5 3 4, and so on and so forth. So this is the basically the whole problem statement. Now we are also given some condition where the given number should not exceed the maximum range of a 32-bit integer. If that is the case, then we need to return 0. So let's try to understand that what is going to be the most common logic to solve this problem. Let's say that I tell you that we are given values 1 2 and 3 and I ask you to reverse it. Logically, as a human, what you are going to do, you will first go to this number, you will find the very last number, and you would put that very last number into the front of this new x that we are trying to create, and then eliminate this number from your side, and once again repeat the same process and repeat the same process for all the remaining numbers. So basically 3 would come over here, 2 would come over here, and 1 would come over here, and this would be our answer that we are going to return. This is exactly what we are going to do to solve this problem as well. Basically all we need to do is just do the modulo by 10 operation for this given x value, and at every instance we are going to do the operation that x is going to be x divided by 10, and we are treating x as an integer value. So this division by 10 would basically yield that we are eliminating the very last element every given moment. So let's see that what is the solution I'm proposing. If the given x is equal to 437, suppose like this, okay, then first of all on this given x we are going to do x modulo by 10 operation. So we are dividing it by 10 and finding the remainder. So remainder in this case is going to be 7. So first of all in our new x we are going to add 7 as the very first value. So basically how we can add this value, basically we will just do like 10 to the power 0 and 10 to the power 1 and so on and so forth. This is how you add digits, and multiply by current value we have and add it to the existing value. So it's very common. Typically we do it with a small operation that we will see in the code. So we would take this value in and we would put it over here. After that we are going to run this operation x is equal to x divided by 10. So that would eliminate this 7 from this existing number. So after this once again we are going to repeat the same operation. Now this time the remainder number is going to be 3. So once again we would append 3 over here and then remove 3 from this existing number, and lastly we will have 4. So we will add 4 over here, and once we have no characters left inside the x, or the given value of x is less than 10, basically we will just add that value and then get out of the loop. Also at the same time we will have to understand that at every given instance while adding or building this number, are we going out of the bounds for the given integer value of the 32-bit number. So for that the only thing we can do is we can just compare whenever we build a new entry for x, and if that entry exceeds the existing limit for the integer or 32-bit signed number, then we will just simply return 0 in this case. So this is the whole solution, and typically this solution would work in the total number of given numbers. So basically let's say that we are currently given 5 numbers, so 1 2 3 4 5, then the time complexity is going to be big O of 5, because we will have to do it for every single character by character. So this is actually going to be big O of logarithmic of x value, where x is going to be the type of system that we use to represent the numbers. Now since we are using 1 to 10 numbers, so this is going to be a decimal system. So simply we can say that this is going to be logarithm of x for the total number of given characters. But overall this is a very simple straightforward solution. And now let's quickly see the coding solution. So first of all, we are going to initialize a new variable called reverse, there where we are going to store the answer, and then we are going to run our loop that while the given x is not equal to 0, we will first extract the last digit, and that is by doing the modulo operation, and then we would simply divide the current number of x by 10, and because it's an integer, so we would just remove the very last character. Now we simply need to check the overflow condition before we start updating the reverse functionality. So we are only checking that if this given reverse value is already greater than the integer by max value by 10, or if that is not the case and if the pop is greater than this value, then we can simply return 0. Otherwise we also need to check for underflow case the same operation in the reverse order, that if we are going out of bounds in the minimum value case. If either of this is the case, we can return 0. If that is not the case, we simply add that value and update the existing reverse number by multiplying the current reverse number with 10 plus adding the pop value or the last value we added, and we can simply return the reverse value. So let's try to run the scenario. Okay, seems like our solution is working as expected. Let's submit this code. And our code runs beautifully, beats nearly 82% of all the other solutions, which is pretty good. So once again, the coding solution is present in our GitHub repository. Feel free to go and check it out from there. Thank you. So this brings us to the end of our NeetCode 150 journey. It's been an incredible pleasure serving you all, and I hope you find my content useful. Let me know in the comments what do you think, and if you completed all part 1, part 2, part 3 and part 4 and nearly 40 hours of LeetCode problems, many congratulations to you. In the comments, can you just write the word awesome? so that I know that you have completed 40 hours and you are being awesome, and it makes me feel awesome. So hopefully you find this useful. Let me know if you have any feedback, and good luck on your interview journey. Take care.